Indonesia holds the potential to lead global climate efforts, playing a pivotal role in carbon sequestration and sustainable development. In response to these global challenges, we are organizing a virtual academic dialogue, part of Indonesia International Sustainability Forum. The event will take place on September 5th to 6th and will be streamed live on the Kemenkomarves YouTube channel. With our moderators, an online discussion where 27 selected applicants will share their research findings. Together, we strive to advance the global effort towards sustainable growth. Supercharging talents to drive success, empowerment, and growth for limitless possibilities. Towards green business transitions, we are expert hub, knowledge hub, talent hub in energy sector, and sustainability concern. Focusing on 4 pillars. Bringing together the expertise and resources, empowering growth and supercharging talent employability, connecting innovation and market, enhancing capacity and building partnerships and networks to address communities' needs and aspiration. We support and empower partner in maximizing positive impacts, in unlocking potential to grow towards a sustainable future.
Assalamualaikum warahmatullahi wabarakatuh. Good morning to all participants worldwide. I'm hoping that all of you are in good health, and it is a pleasure for me to meet you again in this event today. So, welcome to the second day of Indonesia Sustainability Forum's 2024 Virtual Academic Dialogue. Thank you very much for joining us here in this virtual room. I am Vito Rudiani, the academic researcher and lecturer for Department International Relations, Universitas Pertamina, will be your moderator for today's meeting agenda. And our discussion will be delivered in English. So, first of all, I would like to welcome our distinguished guests who have joined us here today. Mr. Rahmat Khaimuddin, Deputy Minister for Infrastructure and Transportation Coordinating Ministry of Maritime Affairs and Investment of the Republic of Indonesia. It is an honor to have you with us, sir. So, with all respect, let's listen to Mr. Rahmat keynote speech.
Kasih tahu ya kalau mulai. Halo, selamat pagi, siang, sore, dan malam pada teman-teman semua peserta Virtual Academic Dialogue. Pertama-tama saya ucapkan terima kasih kepada Ekadin yang telah membantu kita sebagai knowledge partner untuk menyelenggarakan acara ini. Hari ini saya bangga sekali sekarang berada di depan panggung Indonesia International Sustainability Forum supaya teman-teman juga bisa menyaksikan apa yang terjadi di Jakarta hari ini. Tapi tentunya apa yang kita lakukan di sini tidak kalah serunya. Kita berharap dengan acara Virtual Academic Dialogue ini kita bisa mempersatukan semua sivitas akademika, researcher dari seluruh dunia. Kita tunjukkan bahwa Indonesia juga punya researcher yang handal dan tentunya ini juga bisa membantu mempersatukan kita semua. Kita ingin Indonesia itu bisa menjadi salah satu leader dalam pengetahuan terhadap sustainability. Selamat berdialog dan semoga acaranya sukses. Terima kasih.
Thank you very much, Mr. Rahmat. So I believe that the keynote speech from Mr. Rahmat has given us more insights and also spirit. As today we will have all the speakers present their research ideas covering a very wide scope such as technology, social issues, local governments, environmental sectors, and many more.
Recording in progress.
And all the attendees may check the full rundown of the second day agenda at the acadin.org/ISF 2024/, or you can access the official website of Indonesia Sustainability Forum.co.id and choose the option of Virtual Academic Dialogue. As this Indonesia Sustainability Forum or ISF was established as a platform to foster collaboration and best practice sharing across stakeholders in decarbonization actions, ultimately advancing the global concert effort in pursuing a sustainable growth, we are expecting to open opportunities for a wider collaboration among people around the world. All right, so without any further ado, let's move to the presentation session. And I see that some presenters have joined us, but I will first explain the panel's rules. Okay, for the presenters, you will have 30 minutes, 30 minutes for your presentation and also 20 minutes for discussion. We will have a timer on the screen to keep the track of time. And for the audience, you may access the attendance form to claim your A certificate, and the attendance form will be different from the previous panel session. So the technical team will be showing the link for today's meeting on the screen. And in addition, I also strongly encourage to the audience to engage with our presenters so we can have an insightful discussion, and you may ask your questions directly through the Zoom chat feature. And during the Q&A session, I will choose your questions to be answered by the presenters. And also, I would like to remind you, please cast your votes for the nominees for several categories. We will have the awarding session later, after the virtual dialogue finish. So please choose your nominees, use your votes to Choose several categories such as most engaging presenters, most impactful, most visible, most collaborative, most visionary, and most community-centric. And our team will provide the instruction of how to participate this via chat box. Okay, your votes will help us to celebrate the standout contributions and be sure to participate on the last day of the ESF 2024. Okay, so I'm hoping that it is clear to follow, right? So in this very first session, this morning, we will have Ms. Rizka Aprilia Kuswati from Monash University, Australia, who will present her research about application of AI and remote sensing for assessing the impact of energy transition on biodiversity in Indonesia. So, Ms. Rizka, good morning.
Good morning, Manavita.
Yeah.
I'm not alone today. I'm together with my colleague, Mas Vicky, who is also in the
Okay,
room.
welcome also Ms. Rizka partners. Yeah. Okay, are you ready to present your research?
Yes, sure.
Yes. Okay, so you may start now.
Can you grant the access so I can share screen for the PowerPoint?
Yes, you may try again.
I still okay.
Yeah.
Can you see my screen right now?
Yes, clearly.
Great. Okay, good morning, everyone. Thank you, Manavita, for the warm message. So, yeah, my name is Rizka, and I'm a lab coordinator and also a GIS analyst, together with my colleague, who is a data scientist in our research group. We'll be presenting one of our ongoing research projects with the title Application of AI and Remote Sensing for Assessing the Impact of Energy Transition on Biodiversity in Indonesia. So basically, we are from a research group called Mining Spatial Data Intelligence Research Group, who is sitting in a Monash University Indonesia campus. So we are part of the Monash University Australia, but we are in Indonesia, sitting in the BSD, South Tangerang. So before we jump to the presentation, let me introduce a little bit about our research group. So our research group called Mining Spatial Data Intelligence Research Hub. We are multi-year cross-institution and a research collaboration. They are focusing to assess the impact of social and environmental because of the resource development using advanced GIS, remote sensing, as well as artificial intelligence. Our initiative was initiated by University Queensland in the research group called CSRM, or the Center of Social and Responsibility in Mining. Together with Monash University Indonesia, we have a multiple funding from the Ford Foundation, from the Google, and also as well as from the University of Queensland. So we are covering several topics, but for today's topic, we will be discuss about the topic number 4, which is unpacking the social and environmental mining footprint of Indonesia's clean energy transition in resource regions. And our lab led by Professor Alex Lechner, and also led by Associate Professor Dr. Muhammad Rizky Saputra. And we have a core team, me, Rizka, as a lab coordinator and GIS analyst, and my colleague Vicky as a data scientist, and also another team, Nurlaili and Olive. Okay, so our topic for today, the story begins with energy transition. So as we all know that currently, due to the Paris Agreement, the countries pledge to reduce the CO2 level and greenhouse gas emission, as well as to adapt to climate change. And as a result, in energy sector, we have to transitioning from the fossil fuel to renewable energy. But consequently, these renewable energy technologies like solar PV, onshore, offshore wind require critical minerals, or in our research group, we call it energy transition minerals. So ETM, or energy transition mineral, is a specific minerals that are used to transitioning the energy. As you can see here in the figure 1 and figure 2, there are some critical mineral or ETM for energy transition. And the good news is that the minerals with this color letters, the brown one is the mineral that are found in Indonesia. But regarding the critical mineral or energy transition mineral, that transitioning the renewable energy, we also talking about the electrical or electric vehicle that require some ETM, specifically nickel, that in Indonesia, we can find abundant resources of nickel. In fact, that we are the largest and the top producer. And also we have the largest nickel reserve in the world. But because this nickel is the commodity that we have, we need an effort to extract it. We need to clean the land, and of course, it will be potentially harm the environment. So there's a big question at what cost for this nickel extraction to the Indonesian biodiversity. Yeah. So this is, as you can see, as an example of the time lapse of illustration of Indonesian Mineral Industrial Parks, or IMIP, one of the largest nickel industrial parks in Indonesia. We can see a massive of land clearing in order to extract the nickel. So that's why we use a nickel operation as our study case. So there are several of key facts as our research consideration. The first is that mining activities can have spillover effects. So it means that the effect is not only within the boundary of the mining operation, but it's beyond that boundary. And the second one is there's a recent study used satellite image analysis to assess land use change at 3 copper mines, showing results ranging from 5 to about 20 hectares of built-up land needed per 1,000 tons of copper ore extracted. Therefore, to assess the cost of energy transition, we are examining the impact of nickel mining on biodiversity in Indonesia, where nickel is found in Sulawesi and Maluku, region within the Wallace's biodiversity hotspot. These areas harbor unique and mixed species, making the potential environmental effects particularly very critical. So, as you can see in the table, the majority of nickel can be found in Sulawesi and Maluku. Okay, so previously we have discussed about how the clean energy transition could potentially harm the environment and the biodiversity, but how to map the impact on the biodiversity. In our lab, we are using 2 methods for assessing biodiversity impact. First is using GIS, or Geographical Information System analysis, where we measure biodiversity impact based on the mine leases, as you can see in the blue line here. This is the mine leases, or in Indonesian term, we call it izin usaha pertambangan, or IUP. So mine leases basically is an agreement between government and the company that grant the company the right to extract, exploit, and even sell the minerals.
Excuse me, Ms. Rizka, are you still with us? Hello, Ms. Rizka? Okay, everyone, it seems that we have a connection problems here. Hello, Miss Rizka. All right. Yeah. Yes. I don't know how to address Miss Vicky or Mr. Vicky. So, can you do some backup plan or? Yeah. Welcome back again. Is everything all right now? Yeah, I cannot still. I still cannot hear your voice. Please turn on your microphone, Miss Rizka. Yeah, you can turn on your microphone.
Yeah, sure.
Yeah.
Sorry for the technical problem. So which one is the last slides?
Well, it's actually the slide, if I'm not mistaken, the slide 5.
Slide 5.
Yeah. You
Oh,
still
this one?
explain about the Ayub.
Oh, this one?
IUP. Yes, exactly.
Okay,
Yeah,
sorry
you may
for the
continue.
technical problem. Yeah,
Yeah,
I'm
it's okay.
sorry,
Go
my
on.
internet connection is it's not good. So yeah, sorry. Yeah, the last thing is about IUP or izin usaha pertambangan. So basically, using GIS, will be based on izin usaha pertambangan, or we call it mine leases. Mine leases is basically an agreement between government and company. So the government will grant the company an access or a right to explore, exploit, and sell the mineral commodities. Um, and then the second one will be assessing using AI or machine learning assisted GIS, which will be explained more by my colleague Vicky. So the second one will enable more accurate detection as it is based on the mine extent. So as you can see in the red line, mine extent is basically an area, the clear land that is used for the current operation. So imagine that the blue land is the 100% of the permit of the mining permit, and the extent is the current clear land operation in the specific timeline. So yeah, this is the methodology for GIS analysis, the first method. Basically using the nickel mining leases that we got from the Ministry of Energy and Mineral Resources, we buffer those nickel leases into several of impact zones using the buffer analysis with GIS software. So we use 5 zone impacts from 0 to 50 kilometer, and then doing spatial analysis together with several of ecological data set. This ecological data set is basically the data set that represent the biodiversity in Indonesia. There are 3 groups of data set. First is terrestrial ecosystem. The second one is terrestrial biodiversity, and the third one is marine ecosystem. So every group of dataset has its own subgroup dataset. So after that, we're doing spatial analysis, and then we can overlap to know the impact zone of this mining leases that causing the impact. You can see the orange one is the mine leases. And this is the example of the ecological data set in the right one, and the left one is where nickel is, which we doing the buffer analysis for from 0 to 50 kilometer. This is basically the how we calculating the impacted area. So the left one is the illustration of how the buffer zone of the impact overlap with several of dataset. Here, as an example, is the protected areas. And the right one is how we calculate the area proportion for assessing the impact across 13 ecological dataset, where we calculate by impacted area in a blue lines here, and then divided by the area buffer at specific zone. And this is the result. This is the result for terrestrial ecosystem, where there are 5 categories under terrestrial ecosystem. First, protected areas, and key biodiversity areas, and the result reveals that nickel mining has the most significant impact on PAs and KBS within the 5 to 25 kilometer zone from its central mining activities. And for another terrestrial ecosystem data, we know that based on the ecoregion analysis, it is evident that in the 5 kilometer zone around the mining area will be the most affected, while for forest, the highest impact is observed at 0 kilometer zone, which is the mining site itself. And the second one, for the human footprint data, was used to determine whether mining activities are located in natural areas, which is scored by 1, or more in urbanized region, which is scored by 50. So the assessment shows that the mining activities primarily occur in areas with minimal to no human impact, from 1 to 20 score, as you can see in the graph. And this is the result for terrestrial biodiversity. So from the terrestrial biodiversity dataset, we utilize distribution map from IUCN for birds, mammals, and amphibians. And for reptiles, we use global assessment of reptile distribution. And the analysis result indicated that spillover effects correlate with the extent of mining activities with the highest potential impact observed within a 50 kilometer zone, where many species are at risk. And this is the last data set, which is the marine biodiversity. So based on the several of data set under marine biodiversity category, the assessment result for marine protected areas, or MPS, reveal that the highest potential damage occurs within 50 kilometers of mining areas in Sulawesi. And for mangroves and coral reefs, the highest damage potential is observed in the 5 to 25 kilometer zone, while in the Maluku Islands, seagrass shows that the greatest potential damage within the 25 kilometer zone. Yeah, and then the next one is about the second method, which will be using AI and machine learning assisted GIS, which will be explained by my colleague, Vicky.
All right. Thank you very much, Rizka, for your explanation today. Just would like to elaborate further about this methodology that we are currently still progressing. So right now, we basically know that in AI space that there is this subsection called computer vision, right? So this is actually one of the methods that we try to leverage in the satellite imagery. So just imagine that, just leverage this AI ML in GIS analysis, we could actually have the capability to make a further assessment in a more granular level. So yeah, this is basically one of the techniques that we are currently still on progress, by the way. So maybe let's move to the next slide. Okay, so basically in this case, right, we basically have our own data set that we annotate by our geographer, those people who come from geography, geoscience, and remote sensing. So our data set actually has been annotated by them, and then by leveraging existing data set like like Landsat and like Sentinel-2 and so on, we basically try to make a model out of it. So yeah, this is currently still on the development stage, because as we know that when we try to leverage remote sensing or satellite imagery, there are multiple layers other than RGB, right? Like, for example, like near infrared and so on, which is actually something that we can leverage for to improve the accuracy or the intersection of a union. So in this case, right, what we are trying to do is we try to do a segmentation of, for example, like the tailing and the mining disturbance and so on. That's basically what we are still trying to do at this moment. So we have like some initial results in here, and it is still progressing, and we still try to have like multiple experiments in terms of modalities and models at this point. So let's go to the next slide. So yeah, this is pretty much like what happened. Like we have like the RGB and we have the ground truth, which is essentially made by our own geographer and geoscience remote sensing people. which is actually self-annotated, right? And it consists of multiple classes like the mining disturbance, mining bit, tailings, and so on, and the water, and etc. And we perform a segmentation by using an existing open source segmentation model out there, and we have like some initial performance metrics at this point that is currently still ongoing. So let's back to you, Rizka. Yeah.
Okay. Thank you, Vicky, for the explanation. So to conclude our ongoing research, there are several of important findings from our research. The first one is that understanding the ecological impact of energy transition mineral extraction on biodiversity is very crucial, ensuring that we don't focus only for the economic impacts, but also assessing the ecological cost to biodiversity. The second one is using GIS methods. We can assess spillover effects from ETM extraction within 0 to 50 kilometer zones based on mine leases and ecological data sets. For both terrestrial and marine ecosystem, the greatest spillover impact is observed in the 5 to 25 kilometer zones in a scenario where 100% nickel mining in Sulawesi and Maluku is completed. Terrestrial biodiversity, particularly amphibians, birds, mammals, and reptiles, consistently face impacts within the 50 to 5 kilometer zone. However, GIS has limitation due to its reliance on mine leases datasets, assuming that 100% usage of the area for mining. But in reality, it takes 5 to 10 years for a leased area to be fully utilized. So to assess the specific impact by year and location, we are currently developing artificial intelligence or machine learning assisted GIS. AI ML assisted GIS, it will enhance conventional GIS assessment by improving accuracy and automatically detecting mine extent for specific years and areas that we want. And we also have trained models on several locations in Indonesia and in the world. So with the potential for global application in the future. So yeah, that's all for from us for our research project. We are very open to the collaboration. If you want to know more, if you have a question on or want to know more details, you can visit our research group website in this link. Thank you, everyone. Back to Manovit.
Okay, thank you very much, Ms. Rizka, and also Mr. Vicky, who have presented about the use of AI, yeah, to assess how harmful, I think, yeah, how the energy transition, especially the nickel industry, can impact the biodiversity. It's really a nice presentation and also research. I enjoy to listen to your explanation before. So I would like now to open the Q&A session for everyone who would like to ask both presenter. Please drop your question in the Zoom chat. Yeah, let me see first here. Okay, the committee have not shared any question from the presenter. Maybe let me explore more about your research. Yeah. Okay, so congratulations first. You did a very great job on your research, but I would like to know more. When you are developing this AI method or assessment, and I believe that it's very remote, right? You are in Jabodetabek, in part of Jakarta, but you are looking at the very remote area in Maluku and also Sulawesi. So did you work with, I don't know, maybe local people or maybe a local NGO there to help you to assess the condition of biodiversity in the industrial area? Can you explain more about their collaboration that have been conducted until now?
Yeah, thank you, Manovita, for the good question. So basically, we are still based on the available and open source data set from the satellite imageries. So yeah, we haven't done any field activities to maybe with local communities, but we also have some workshop with NGOs to her about their concern, and then to make their research finding or the publication which they already assessed with local communities is also considered in our research. So far, we haven't done with local communities, but hopefully, after we have a good result for this AI assessment, we have planned to collaborate with local communities.
Yeah, okay, yeah. Actually, how long have you conducted this research?
Maybe Vicky, we haven't
Since this
it's
year, last year?
it's ongoing, so it's ongoing from probably like 2020.
Yeah, I
Oh,
think
okay, for the last 4 years, yeah? It's
Yeah,
almost
but
4 years. Ah,
yeah, but actually we are not just doing one research. We
yeah,
also
yeah.
in parallel with another research, like we also conducted a research in terms of policy. So it's
Ah,
parallel with another research. Yeah. So it's basically one of some of our ongoing projects.
yeah, okay, yeah. I understand, yeah, because when you are trying to assess something, take a picture, a big picture of a problem, it will be necessary to look at the very detail condition. Yeah, so maybe after this, I mean, you did a very great job on the background and also the result so far. But yes, I'm also hoping that you can collaborate more, especially with the local government or local community, because I think something is going on in Indonesia regarding the downstreaming, yeah, the nickel and also other critical minerals due to the president's regulations. But some people maybe I cannot say they forget, but maybe this biodiversity seems like a condition that people don't understand more, and also how this policy of downstreaming the critical mineral can impact the biodiversity. So everyone who would like to collaborate with Ms. Rizka and also Mr. Vicky, please do not forget to drop your questions. And also maybe you can have a further contact with them through the link that have been shown by Ms. Rizka. Okay, so my next question will be, until now you are looking for the I mean, almost the whole biodiversity, right? Is there any specific research regarding the endangered animals or maybe plantation? And are you focusing on those kind of issue?
Yeah.
And yeah,
So
endangered animals or plantation.
yeah, basically we are still focusing on the helicopter view of the biodiversity, which is represented by four taxonomies. So there's a bird, mammals, amphibians, and reptiles. But we also plan to focusing on marine biodiversity as well. There are several of the fish that potentially harmed by the nickel mining activities. We also have several of news about the fisher traditional fisher that lost their job, and the fish also the level of fish also reduced in the ecosystem. So we plan to also consider that in our current ongoing research.
Okay, so you basically focus on the scope of the area and also the biodiversity inside, right? Okay, good. Okay,
Yes.
so there is a question from Paul Sarjat. Yeah, how you can also see that in the chat box. How are you incorporating the dynamics of species ranges and potential habitat shift due to the climate change in your analysis?
Thank you, Paul, for the very great question. So yeah, for the dynamic of specials, actually we are still using the IUCN data. So there are several of data there, like the presence, the original, and also the season. So based on these three categories, we can explore more, and we are currently using the presence or the level of the animals that currently in that specific times where IUCN publish the data set. But yeah, hopefully we can collaborate with local researcher there so we can assess directly the level of dynamics of these species.
Okay, thank you very much. And also there is a question from Gavin Bestralan from the Ministry of Energy and Mineral Resources. I believe that everyone is interested to your research because this is very important to maybe can prevent further damage to the biodiversity. Hi, I'm Gavin from the Ministry of Energy and Mineral Resources. This is a very useful as a tool in providing data support for national strategic projects that must be provided by company because, for example, they argue that they support the energy transition by building mounted solar power generation, but changing the land status. How about possibility to use the research?
Yeah, thank you very much, Gavin. I'm very happy to hear this news because we currently open, especially to the government, the potential of using our research. So basically, if we have like a very significant, a good result, maybe in the 1 or 2 years, so we can use another data sets, like we can using data set from another ministries or data set about the potential of energies or data set about land issues. We can simply overlap to the segmentation, and we can get exactly which one is the issue, which area that we need to solve as soon as possible so the government can focus on a specific zone. And yeah, the possibility may be within 1 until 2 years we can get the good result, and we will trying to approach to the government as well as the companies, especially in terms of nickel mining, to assessing to make this assessment in their life cycle assessment, for example, or in ESG report. Yeah, hopefully we can get as soon as possible.
Yeah, hopefully everyone can collaborate, yeah, in this research because it is very important. Okay, so my next question will be, what is the biggest challenge of this research, and how so far your team can handle this kind of challenge?
Thank you for the good question. So far the challenge is about how to get a large sample data set to train for the AI. So maybe my colleague will explain more, but not only we use open source and available data set that we can access, like Google Earth Engine, or maybe the data that we can like the open source satellite imageries, but we also collaborate with some university, like university from China, one of the university of China. We also try and some of the people there to get more sample, but yeah, maybe it will be explained more by my colleague.
All right. Thank you, Rizka, for your explanation. Just would like to elaborate further in terms of some challenges in for technical deliverable. Like, for example, when it comes to machine learning, right, we need like a data set, right, in order to train, right? Because essentially, when it comes to machine learning, it is garbage in, garbage out, right? It depends heavily on the quality of our data as well. So basically, at this point, right, one of our challenges is basically of the limited training data that we have right now. Like, we only have like around 100 train data set at this point that we actually got from Google Earth Engine, right? And again, right, because of that alone, it actually has like a limitation in terms of how to actually improve further on in terms of the accuracy and IOU, right? At this point, right, it is quite challenging as well to actually find like a high quality open source satellite imagery data, especially for mining extent, right? And that's actually the reason why, you know, we had like people coming from remote sensing and geography background to actually annotate our own data set in this case. Yeah, obviously there are several techniques that we try to utilize and experiment, and it is still currently ongoing at this point. But yeah, I would say that the biggest challenge, one of the biggest challenge, is basically the amount of data set that we currently have due to the limitation of the mine extent data set out there as well in around. Yeah.
Okay, thank you very much. Let's see if there are any question from. Oh, there is a further question and feedback for Paus Raja. So the question is, how are you integrating the social and economic consequences of nickel mining into the overall impact assessment? Are you considering factors like displacement, community livelihoods, and social equity? Please.
Thank you, Paul. Such a great question. So far, our project it divided into two projects for these topics. So the first one is the assessing the social and economics impacts, which we are doing the collaboration with University of Queensland. So for this research, we haven't used the social and economic consequence because we are focusing on the environmental impacts, which specifically in biodiversity. But for another research, the ongoing research that may be published next year, is focusing on the policy and implication of the nickel mining. So we are using several data set from BBS or Badan Pusat Statistik, like the poverty rate, the migration data, and the population density, as well as the Human Development Index in Sulawesi and Maluku, combined with GIS analysis. Some of this data from this research is also used for that research. So we will combine it with using those data from 2009, the first of mining law revolution, and then we also assess the year of 2014, which the year of the first phase of downstream policy, and then the second one is 2020, the second phase of downstream policy. So it's actually in another paper that is also running in one of in our lab.
Okay, thank you very much, Miss Rizka. All right, so as the time is very limited now, maybe I will giving you a question, so you can answer and also continue with your closing statement, right? And also promote yourself to be voted by the attendees. What is the main goal and also further expectation from this research?
Okay, thank you. Such a good question to conclude the research. So hopefully, our research will be used not only helping the government to efficiently extract the mineral for the energy transition for the Indonesian context and global context. We hope that they only consider economic value of the nickel extraction, but also considering the effect to the environment, to the biodiversity, people, the animals, or the living beings that are living nearby of the nickel or mining area. So hopefully, the assessment will be used for the report for the companies or maybe the policy, so that if we can involve it in the policy, the companies that running the mining operation will follow or obey the rules, so we can have a sustainable and responsible of mining operation that will support the clear global energy transition.
Yeah, agree, totally agree. Yeah, we are expecting the what's so-called research-based policy, because we see now that lots of data and lots of research has been conducted, but I'm afraid that it is very little to be considered as the policy in Indonesia. So hopefully your research can make a good contribution to our country. Thank you very much, Ms. Rizka, and also Mr. Vicky, who have already presented about the assessment regarding the biodiversity in Indonesia and how it can be impacted from the energy transition. Don't forget to vote them, everyone. So please use the link that has been shown or shared by the committee. So yeah, so you can see more collaborative ideas from Ms. Rizka and also Mr. Vicky. So thank you very much once again, Ms. Rizka and also Mr. Vicky. Look forward to have a further collaboration with you in the Monash University. Please give our greetings, warm greetings to your team, and hopefully you will be doing a great research in the future. All right, so I see here that many people have been interested and also engaged with the discussion. And I think we shall continue to the second presenter. Yeah, I see here the presenter has already joined us. So we will have Mr. Isaac Cornelius from Institute Teknologi Bandung, and he will present about assessing feasibility of renewable energy integration in ASN4 residential complex at Ibu Kota Negara or IKN, a green building perspective. Let me greet him first. Good morning, Mr. Isaac.
Okay, good morning, Miss Novita. So,
Okay, could you please turn on your camera?
basically, I have opened the camera.
Oh, okay. Yeah, we can see you now. All right, so your presentation will be 30 minutes, and also it will be followed by the Q&A session for 20 minutes, right? Are you ready?
Yes, so I will be presenting this research with all of my team. So each of us will present each part in this one device. Okay.
Yeah, sure. You may start.
Okay, so good morning, everyone. Thank you for joining in this presentation. We are the Harmony team, and today we will present the concept of green building based on self-sufficient residential sector and supporting the ultimate goal of achieving 100% sustainable energy cities, and it could be possible to the world while ensuring the smooth transition towards this visionary. Okay. Okay. So, oh, sorry. I think I have some technical problem. First, let me fix it. Okay, so for our team consists of 4 members, including me, and there is Juan Leonardo, Olivia, and Fajar, who will be joining with me to present this research. We are currently third year students in mechanical engineering major and Institute Teknologi Bandung, and we all have strong interests. We have all this interest in, especially in sustainability, and we want to contribute to support the energy transition, and we want to apply our alternative HVAC systems, especially in the certain building that we will discuss about. Okay. So,
Okay, next we will talk about our background. First of all, is our government supports the Republic of Indonesia has a strong commitment to successfully relocate the capitals from Jakarta to Nusantara. This evidence is the evidence is the budget. The budget for relocating the capital city is for 166 trillions rupiah, and that is a significant number. And the government commitments is using 100% renewable energy utilizations. This is a revolutionary steps for energy, and it is aligning with our visions, with our government good intentions. Additionally, this commitment is being realized through constructions of solar power plants which is a fact, just not the words from our governments. The next about our background is the government commitment. Our government is committed to continuously enacting relevant legislations for this positive development, because the idea need to be backed up by concrete actions such as legal frameworks that facilitate the implementations. For instance, as the legislations, we have UU number 21, 2030 about Ibu Kota Negara Baru, and then PP number 79, 2014 about national energy policies, and Perpres number 22, 2017, which encourage renewable energy involvement. Moreover, the accompanying graph illustrates in the right side shows that there is a rapid growth of solar and wind power plant in Indonesia year by year until 2023. Therefore, we are increasingly convinced that exploring the use of solar panels in residential building is very compelling idea, but this not only meets the building needs, but also not burdening the central grid, which is can be better focused on government activities, but also allows the energy generated by as and for residentials to be shared to surrounding buildings, not just but on maybe it also can be integrate with cities' energy storage systems or smart city battery scales. The next things about our research. Initially, we are quite confused which one is more relevant, carbon neutral or green buildings. But eventually, we are decided to choose green buildings because it aligns with our idea to study about the substantial aspect about how to make the building can have much more positive environmental effect. And green building takes a lot of more holistic approach from various fields to success the idea. The method will carbon neutral building is just basically make the carbon emissions equal to zero. So sigma carbon is equal to zero by have some offset in carbon capture and something. But while green building is using the resource that we have to make the building have more capability to make a good environmental impact, the water management and much more.
Okay, so to achieve the goal to make a green building concept possible in Indonesia, especially in the new capital city in Nusantara, we dive deeper into all kind of supporting things that already available there. For example, the most important thing is the climatology background. So in IKN, the climate is quite supporting for our concept here. Basically, first we can see at the potential of the groundwater already exists in IKN, which is quite abundant, which make sure that IKN will almost possibly never get low or scarce of water for the city. So we thought that maybe we could take this abundant resource to help improve our concept. And we dive deeper to the groundwater utilization for a new concept of cooling system for the buildings and so on. And also we do research based on open source available
available open source resources. We dive from the official site of IKN from PUPR and Roblox map, etc. to the surface, something like surface, because we have limitation in budgets and so on. This is what we do to make sure our data is quite.
Okay, so let me continue. There are basically three main aspects that we will consider about. So the first one is the eligibility or feasibility study of the integration between renewable energy and the specific building, which is SN4 residential building. Is it possible? Is it integratable with renewable energy? And the next aspect we want to analyze is the utilization of PV, our PV system. So we have designed our PV system, and of course with our constraint, we designed the optimum PV system for according to the electricity needs or the electricity demand, and also the pattern of the society use. And the third one is how we use this electricity from renewable energy to make the cooling system to activate the alternative HVAC system. Okay, so in details, we first analyze in the next slide we will explain about the power generation, and then we will consider the patterns or what Indonesia society use the electricity. The next one is we manage the data from the pattern to our PV system. And after that, we consider the usage of HVAC system, how we design an optimum HVAC system so that the society in ISN4 residential building could feel comfortable. Okay. Okay, moving on to Olivia.
Okay, next we also consider the significant daily electricity load. There is the literature study about forecasting Indonesia's electricity load through 2030, and we can see also from the graph the peak demand of the electrical use. This graph illustrates the trend of the average use for each electrical appliance. We use these trends as a basic for considering expected load later on for calculating our system. Okay. According to what we have read from the article of the developer itself, from PT Brantas Abipraya, they said that each building consists around 12 floors, which have 6 units of each floor. Okay, each unit is around 96 meters squares. For the first and the second floor are used for public spaces like fitness center or auditorium that can be used for all. And then we also define the basic electrical units that will be used for each household. For instance, lamp, TV, rice cooker, or even our HVAC system. And we get around 730,000 watt-hour per day. And that's all for the calculation, the total calculation. And this is the detail of the load profile that we are going to use for our analysis later on. As we can see here, the blue graph showing about the daily consumption that shows quite different from our from what we have already assumed at first. This graph looks like this because of the HVAC system that will be used, and this HVAC system will need electricity source from around 8 a.m. to 5 p.m. at noon. The peak of the graph will be around 9 a.m. in the morning, since at that time we assume that people are started to prepare themselves to go to school or even to go to work.
Okay, we also have analyzed the tilt angle and azimuth angle. Shortly, this is our configuration of plane tilt angle and azimuth angle. So let me continue. As discussed before, we use PVSys as our analysis software to create the PV system because of its ease, and we can set many parameters as we want to ensure that the usage of our PV system will get optimum. Okay, so this is the configuration of our PV module. These are the specifications. These are the PV module and inverter that we use. As you can see here on the right side, that's the quantities of each specification. We have also considered the thermal losses factor. We set the limitation that the air circulated freely on the models. So the module efficiency loss and LID loss had been set as default from based on our PV module brand. We also consider the maximum power peak, the ability of panel to receive solar energy gets reduced. Definitely, we see the usage majorly contributed from household. So we set our parameter, we set our assumption that Rusun, ISN for residential building, majorly the consumers is household consumers. So we set the parameter on the left side. We assume there's no volatility in electricity demand every year. So we set the household profiles is constant over the year. As you can see on the slide on the right side, these are the specification. These are the numbers of each part of the system, including nominal PV array and so on. Okay, according to our model, we also do the shading analysis. As you can see on the bottom left side, these are the irradiation or shading loss graph. In detail, you can see that for about 4 to 5 p.m., the shading loss involve the irradiation of the sun. And roughly the irradiation starts to decrease after 7 a.m. and the shading loss start to disappear. Okay, this is what we have analyzed so far. The most important thing is the performance ratio, which is the ratio between the generated electricity directly from the sun and the output of the electricity itself. So we get about 81.1%. So we get the value of the performance ratio above 80%. And on the left side, roughly we analyze the global horizontal irradiation. We get about 4.447 kilowatt hour per square meter per day. We have taken this from based on historical geographical data, and which about 16,000 kilowatt hour per meter squared a year.
Okay, next, talking about the green building, that we believe that green building concept is aligned well with our visions. Actually, this concept is not actually new. It has been widely adopted around the world, but traditionally, building have been just set for a structure that leave a carbon footprint, but now we aim to shift it towards to much more positive approach, where building can be used to reduce environmental impact and contribute to environmental preserve. And we hope that it significantly enhance the quality of life for the occupants. Next, referring to this project, we use the Green Ships guide for new buildings because it's the most easiest document that we can access. There are also some aspects that we not review in details because since we are all mechanical engineering, we feel that it can be more appropriate to us to discuss about fields that we learn in the class, such as maybe the electricity systems. We plan to install kWh meter on every load system, so with that we can surface and look forward for our load systems. And then is the natural lighting. Since the green building concepts require natural lighting, it give us a limitation that we will install the solar panel in the rooftop, not in the wall, because of it can reflect the suns. And since the sun's light is the requirement, we want to make sure the sun can go through the buildings. Next is the water management. The water management is not also ensuring about the cleanliness, but also making the water effective usage. In our FEHC, we are also design the systems that use the local water resource, and then we also avoid the heat island effect, especially when we want to pump color from our room to outside. It can make the surroundings temperature of the building hot. If we design HVAC systems that not met this requirement, it will be a feedback looping, and I think it's not that good for energy usage. We want the energy become more effective, right? So the next is the heavy AC systems should be introduced the fresh air from outer air. The considerations is highly concentrations of CO2 is not good for our health. We want to introduce the natural air so we can improve the O2 levels in the buildings. And next is the refrigerant. About the HVAC systems, we want to design the refrigerants that use not harming the ozone layer, because this is dangerous, can lead us to maybe more greenhouse effects and increase the global temperature, which feedback looping. And we want to use water-based refrigerants that utilize the temperature of surrounding waters, according to previous point that we want to use local water resource. And our goal is to maintain the temperature of the building is 25 degrees Celsius and the humidity is 60%, which I believe are the best condition for humans to work, to live, to perform the activity, because better air leads to better performance of the employees.
Okay, next. As we told previous, we also dive deeper into the HVAC system, how we improve the HVAC system in the building, so it could go in line with the profile of the sun-generated power, solar-generated power. So, generated power kind of load, kind of generation profile, it always have a peak of power production in around 6 a.m. to 6 p.m. Basically, when the sunlight is directing to the earth, right? But we have problem here where the cooling system, especially in the tropical areas, city like the Ican itself, it always being the main contribution to the power demand in the peak hour, as we could see from the graph we also discussed earlier. Which is happens in the night when everyone is in their home, in their sleep time. There is different in between how the power generation and power demand, right? So we try to linear. We try to meet those two factors with how the power generation works and the power demand are. So we design a HVAC system which adapt all the already available technology in the market, such as evaporative cooling, etc. But when dive deeper into it, we try to still sticks to the code of the green building guidance. We use water as its working fluid. We try to circulating water to exchange heat inside. We also direct cool outside air in IKN into the buildings. We try to improve all of that into a system. Here's the background, the more climate background and everything that we do research for this concept. Basically, the groundwater availability, the average humidity there in the IKN, average temperature, the available technology, the integration of ice as its working element to cool the building, which will be something like this. Basically, the concept is we direct water as the cooling system, integrate between the indirect evaporative cooling system with a chiller, which will work at night, and this direction of cool outside air in IKN. We do the system which will make ice in the daytime, which is when the solar generation power is abundant. We maximize the power generation to make ice during the day at about a metric ton an hour. So we get around 8 metric ton of ice in the nighttime to chill the water and circulate into the building. So the building could have a circulation of a really good condition of cooling system. Here's the simple schematics of our system, which in daytime we integrate the cold groundwater circulation with our indirect evaporative cooling system. At night, we integrate the indirect evaporative cooling system with the circulation of ice-cooled water. So it will produce about 10 degrees Celsius, at least 70 degrees Celsius cool air circulation in the duct with the flexibility of controlling the temperature in each room with heating coils that we put in the ducts in each room. Here's the prototype that we already make as a proof of our concept. It basically worked quite promisingly.
Okay. Apart from any technical problem that have been explained before, we also consider about the economical value for this project. There are actually 3 main points that will be highlighted. The first one is the electricity daily load. The second one is LCOE. And the third one is ROI. And for these ASN for building residential building. And the electricity daily load will estimate the load profile, the load profile for the use of the electricity in this building. While LCOE is levelized cost of energy, and the last one is ROI is the return investment of for this whole project. Okay, for this installation, we need around 10 pieces of 12 kilowatt AC inverter, which costs around 240,000 rupiah. And we also need quite much of PV modules. Apart from this system, we also need cost for installation and also operating. Which these costs also include about cleaning and also repair for each year. Okay, the next one. We said this project will last around 20 years lifetime. We also said the inflation rate will be around 3.71% each year. From some sources said that the consumption rate per today will cost around 1,150 rupiahs per kilowatt hour. For calculation itself, we also input the nominal rate of electricity if there are some surplus energies. Since this is also government building, we also assume that the surplus energy can also be sold to the electricity grid, which with the specific nominal rate. Based on the executive order from 2022, we believe that the government is also supporting about acceleration of renewable energy development for supplying electricity source. And next, for expenses for this project, the levelized cost of energy is around 556 rupiah per kWh, and the payback period for this project will be around 9.3 years. And for the return of investment is around 190%. As we see from the system summary, we also sell the surplus energy to the grid, which around 82 hours per year, and consume around 139 megawatt per year. Okay, actually, this is the loss diagram of the system and the number of the safe carbon dioxide emission from the projects.
Okay, so let me sum it up. Based off our presentation, we could take 5 key takeaways. As you can see, the important points. The first one is we have analyzed the global horizontal radiation. We have estimated the energy needs based on historical data. We create a constraint, and also we have defined our PV models and inverter. And the next one is the key point is the design PV system projects. We get the ROI of 191.4% for 9.3 years. I mean the return of investment time with the average cost per kilowatt hour is 556 rupiahs. And we have give the alternative HVAC system integrating indirect evaporative cooling, groundwater circulation, and ice-based water cooling. So thank you for joining us in our presentation. If there is any questions, let us know. And my final word is, a good research always leaves a question. Thank you.
Thank you very much, Mr. Isaac, and also team. Lots of people back there, I see. So yeah, this is a very great job for the team to analyze the existing issue in the Ibu Kota Nusantara. Okay, so I would like to invite all the attendees who would like to ask a question or maybe jump into the suggestion for the further research. Please drop your ideas or question in the chat box, so I will read that to be answered by the presenters. Okay, so once again, thank you very much. Let's go and move on to the Q&A session. Maybe I will start the question first. So you are assessing the feasibility of renewable energy integration in the residential complex, yeah, for the ASN. So actually, if I'm not mistaken, there is for the ASN housing, yeah, there will be 8 buildings or 8 towers, and the existing towers is still, I don't know, 6 or 3 towers, right? Because they will be step by step in building the housing for the ASN, if I'm not mistaken. From the news that I read, is actually there will be approximately 8 towers for the housing for the ASN, and until today, until September, the contractors, if I'm not mistaken, Brantas Abripaya, yeah. Brantas Abripaya is expecting 6 tower to be done in September 2024. Is it true?
Yes, correct.
Yeah. Okay. So my question will be, you are assessing the existing towers, yeah, and hoping that your research can be implemented to other towers, or are you expecting your research can be implemented to other housing, not only the ASN housing, but also other buildings in the IKN?
Okay, so thank you for the question, Mr. Vita. So as we explained before, we have to analyze the electricity needs. We have to analyze the fluctuation of the energy demand, whether it's at noon or at 5 p.m., 6 p.m., when the electricity reach the peak, its peak. So in this context, we first analyze the ASN residential building. Why? Because we can get the same. I mean, we put our constraint that each of towers has the same electricity needs. But maybe in future research, or maybe in our next research, we could analyze the other building inside IKN. But literally, we have to analyze, we have to consider the electricity needs once again.
Sorry, so to add up to the question, the answer is yes, we try to make the Rusun SN Park as a model for our concept. Basically, we try to make a concept that is applicable to any existing residential building. We could implement this concept into any building that have a ducting system for a cooling system previously in conventional ACs, where we could change the HVAC system to this model that we try to design right now.
Okay, thank you very much. So you are still focusing on the ASN residential buildings because they have approximately similar electricity needs. That's why hopefully it can be implemented for the next plan of the buildings, right? And also in the future can be implemented also to the other building in the IKN. Okay, thank you very much. This is a very good start of the research, and I believe that yeah, you say in your research that the apartment complex is very stands out, yeah, because it has so many towers inside that, and also it is very close with the government buildings, right? Okay, so my next question will be the economic. I cannot say about the investment, but it's more to the procurement of the materials that you need, such as the photovoltaic technology and so on and so forth. And you claim at the end of your presentation, all of you claim that it can return the investment as much as 194%, if I'm not mistaken. So it's almost 200%. How long this can the investment return can be achieved?
I think this is field of my research. Okay. We have also mentioned before that the payback period of this project will be around 9.3 years, and I think around this time, this is where the return of investment occur, and also this is the since we also said this project will last a long 20 years lifetime, so around 9.3 years we believe.
Okay, so in almost 10 years, if there is no specific or major issue, the return of investment will be achieved in around 10 years. Okay, so it's quite interesting, I believe, for the investor. Hopefully the government can attract the investor to put their investment in IKN. Okay, thank you very much. Let's see here. Is there any question? Okay, not yet. Please, everyone who would like to ask the presenter, because I see here that today's presentation from the very early in the morning until now, all the topics are really interesting. So I believe that you can engage more with the presenter, and hopefully after today's agenda, in the future, you can have more collaboration with all of the researchers here. Okay, so my next question will be about the maintenance. About the maintenance. You say that this you have already evaluated about for the existing housing or buildings, and then hopefully your research regarding the HVAC design can be implemented to other buildings. So have you ever considered how the maintenance program will be conducted? I mean, I believe that this is not only the homework of the Brantas Abripaya as the constructor, but also for the people who live in the building. So how easy the maintenance things will be, because it's really high technology. I'm afraid that not everyone can understand. So is it possible for the people who live inside the buildings can do the maintenance program?
I think at first we have already set for special nominal value for the maintenance program. So at that system summary, there are also stated that we set around 100 million rupiah each year for maintenance. And for the detail of the maintenance itself, we have not dive into how we can actually clean the HVAC system, but we believe that the system is quite simple. And I think that everyone could clean it by themselves. And apart from that, we also set for several human to also help us to clean the system and or also the PV module itself.
Okay, so until now, you believe that there will be a specific team who I believe to observe or to do the maintenance system, right? So the residents, the people who live inside the building can pay them directly. So the team will do the maintenance system. Okay. So I believe that my question is regarding to your literature review, right? So when you are proposing this kind of idea for the ASN buildings in IKN, you must be doing what's so-called benchmarking to other condition. Did you do that to other region in Indonesia about the green building? And so you come to propose this idea? Did you do that? Benchmarking?
We have not done any benchmarking before. So actually this is just we just reviewed this for at least 3 months prior, but I think for the later future, I believe that this system, I think we will expand it more, or even do more systematically review on this project. But until now, we just we have some limitations on these projects, so we just do until here and with these specific specific environment.
No, it's really good. Yeah, it's okay if you haven't conducted any benchmarking yet, but I believe that this is a very good start because, when people came with ideas, sometimes they have problems how to conduct it, but you do a very detailed in the beginning. Yeah. So I believe that hopefully, yeah, many people are interested to implement this kind of ideas and proposed project for the IKN. Okay, everyone who would like to deliver the question, please. Yeah, I'm sorry, this is very personal, but are you all the students from ITB?
Yes, we are all from Mechanical Engineering Study Program. We are from under Faculty of Mechanical and Aerospace Engineering from Institute Teknologi Bandung.
Oh my God, good. Really, it's really impressive. Yeah. In which year you are now?
We are currently third year.
Third year. Okay, good. This is very good. I think, yeah, we should support the young generation research because, yeah, a lot of researcher who have already presented their research is mostly PhD or master degree, and this is very great for the undergraduate students who are very brave, I think, yeah, to come up with this idea. Okay, so my next question will be, if any one of you have ever visited the IKN?
Uh, no,
Oh,
we
not
have,
yet.
yeah,
Okay,
we are from until now we just do the literature review and based on the source from the internet itself.
yeah, okay, yeah. Hopefully after this you can see directly the IKN. So hopefully it can also gain your knowledge and also insights to improve your research. Okay. So there is a different specific regarding the air cooling system and also electricity and so on and so forth. So my question will be, have you ever, I don't know, have you ever considered or mapped the stakeholder who can monitor or who can support your ideas to be implemented then?
Yes. We look for like the contractor for these buildings, for example, yeah, Batas Abipraya. So the main interest when we first dive into this concept, the green building and HVAC system, we thought that IKN is a brand new canvas that will be painted like it is easy to make concept about IKN because it is a brand new city, like start from scratch. That's also why we take IKN as our example. So yeah, maybe for investors, we of course need to do further research about this. Like actually, in our paper, in the paper that will be released very soon about this title, the same title as what we present today, we already detailed about the maintenance, about the technical things that we need to calculate in this concept. Yeah.
Yeah, after this, yeah, hopefully lots of people will be joining your research for collaboration because something on the paper can be really a good and concrete contribution if you implement it in reality or in real life. Okay, thank you very much, Tim. Let me check here. Is there any not yet? Okay. So maybe this will be my last question, and hopefully you can answer it and continue to your closing statement and also promote yourself for the nominations. Okay. So what is your expectation? Yeah, for the research especially, and also how to implement these ideas into the implementation. That's my question, and please answer that and continue to your closing statement.
Yeah, thank you for the questions that we believe our ideas need supports, especially financial supports. So the idea can runs that well. We have good intentions. We have good preparations and research for this. My hope is, I hope that the idea can be implemented. It's not easy, I know, to change from to change to renewable energy. It's all about the financial needs. So yeah, we're open to sponsors or maybe donator that can support us to continue our research. Maybe how to we can to observe the IKN in the IKN, or yeah, maybe enhance our quality of PV research and much more. We believe that a good idea will be helped with a good support too. So our closing statement is thank you very much for this appreciation and time. We hope that the idea can be developed well in the future, because we are still young. We're start our semester this Monday, so we hope that yeah, any one of the investor can be look for and help us with the financial aid. Thank you very much.
Okay, thank you very much. Is there any addition from other members who would like to say words? How many people are you there? Can you stand
Okay.
together? 4 people, I think, yeah, or 3.
Four. We are
For there are 4 of us. Yeah.
Okay, 4 of us. Okay, Mr. Isaac, you would like to say something? Please, we still have time.
Yes. Okay. Thank you, Ms. Nopita. I would greatly appreciate for all of my partners, Juan Leonardo, Muhammad Fajar Yusuf, and Olivia to together conduct this research. Although we are still in third year undergraduate student, we believe that we could develop our potential to its maximum peak. And also we could collaborate more in the future to other major students, other major undergraduate students, maybe from from electrical engineering and so on. I'm so happy to present with 4 of us, but not just myself. And as the PIC, I cannot do this without all of my partners here. I'm so happy. I'm so proud of them. Thank you.
Okay, thank you very much, everyone there. Congratulations for your research. It's very good stepping stone. Yeah, please deliver our warm greetings from the ESF committee to your lecturers in ITB, and good luck for Monday as you will begin your new semester. And I'm hoping that you can be consistent in your research, and also in the future after you graduated with the ITB, you can implement all your ideas that have been presented here and also during your study in ITB. Okay, thank you very much once again, everyone. Have a very good weekend. Yeah. All right. So everyone, I really appreciate your participation in this agenda. Yeah. After this, we will have a little longer lunch break. Yeah. So I believe that everyone will do regular weekly prayer, yeah, Salat Jumat. But I would like to remind you that we will have to choose to several categories. So cast your vote for the nominees for the these categories, and maybe I would like to ask the committee to help me to show the recent update of voting result. Yeah, please, the committee. We actually have 6 categories from the all the presenters, and there will be 6 winner or nominees who will win the each categories. There will be most engaging presenters, most impactful, most visible, most collaborative, most visionary, and most community centric. Yeah. Okay. So please draw your vote to choose the best nomination through the voting link, which has been shown by the committee earlier. and we will have 6 teams who will be acknowledged as the best nomination from these 6 category. Okay, so please everyone, all the presenter, you can promote yourself to be voted or to be chosen by the attendees, by the people out there. Yeah, just share the info, share the news, share the links, and the committee will recap the result, and at the end of this day, at the end of today's agenda, there will be the announcement for the winners. Okay. And also, please do not forget to sign the attendance form to claim your certificate. Yeah, I believe that the committee also shared the attendance form link through the chat box and also through the screen. And please use different link because I believe that we have several attendance form for each panel session discussion. Okay, so now we will have a little lunch break, yeah, and the next agenda will be starting at 2 p.m. Jakarta time. So after lunch break at 2 p.m., please come back again to this room to continue the discussion. And my best colleague, Ms. Rahayu Lestari MT, the lecturer of IPB University and PhD candidate of Bandung Institute of Technology, will conduct the panel. Okay, I will to see you again very soon, everyone. Yeah, I wish you all the success for all the presenters. Thank you very much, and have a good lunch, everyone. See you after 2 p.m.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to everyone. I'm hoping that we are all in good health and a good spirit to start our agenda this afternoon. It is a pleasure for me to meet you all in this event. So welcome back again to our afternoon sessions, the Virtual Academic Dialogue Indonesia International Sustainability Forum 2024. So first of all, I'd like to introduce myself again. So my name is Rahayu Lestari Sugihartini, and I'm currently a lecturer in IPB University Indonesia, and previously completing my bachelor's degree in ITB and master's degree in University of Indonesia. So I will be moderating the discussions in these sessions with Ms. Cynthia Jaya Putra. And I see here Ms. Cynthia Jaya Putra is already online.
Hi, can you hear
So
me?
yeah, yeah, hello. How are you?
You all good, all good.
All good. So yeah, nice to meet you.
You as
Okay,
well.
so yeah, I hope we can have an insightful and engaging discussions this afternoon. Also, a little reminder that the presenter has 30 minutes for the presentations and approximately 20 minutes for the discussion sessions. And we will also have a timer on the screen to help us keep on track of time. Okay, great. So maybe Miss Cynthia, let's start our discussions. The speaker here is Miss Cynthia Jayaputra from King's College London, with the topic of biochar subsidies, a policy proposal for accelerating carbon removal in Indonesia. So without further ado, the screen is yours. Thank you.
All right. Thank you so much for the floor. Let me share my screen. Okay. Can you see the screen?
Yeah.
Great. Okay. So hi everyone. Thank you so much for Barahayu for the introduction. My name is Cynthia. Very nice to be here. And today I will be talking about my policy proposal specifically regarding biochar subsidies to accelerate carbon dioxide removal in Indonesia. So before jumping into it, and to start off, I graduated from King's College London, studying international relations. And throughout my time there, I was exposed to a lot of climate policies, and I jumped into it straight away. At first, I was fascinated with renewables, and I was fortunate enough to get an internship in EMITS in Indica Energy. They focus on solar panels. And so I started there, learned more in Indica Energy, and be exposed to the carbon markets throughout my time writing my research paper. I spoke with brilliant people in the carbon market sector, specifically in Indonesia and Southeast Asia, such as Pak Darsono from Rimba Makmur Utama, for example. And so throughout my time finishing my university this year, I also got an internship for 2 months in Allied Offsets. It's London-based. I was a carbon dioxide removal analyst. And yeah, it's basically a data company specifically on voluntary carbon market. And so throughout my time there, I knew that I want carbon market as my niche. And yeah, right now I'm working as a sustainability consultant at Turner & Townsend. Okay, so just for introduction and briefly touch upon the carbon markets, it's very important to distinguish between the two types. First is the compliance carbon market, or the CCM, and second is the voluntary carbon market. Now, CCM is a mandatory emissions trading system. So if you've heard about EU ETS, Japan GX ETS, for example, the cap and trade system, that's compliance carbon market. Now, VCM, on the other hand, is more on voluntary carbon offsetting market. So it means not only the government of emitters, for example, it's also corporations, and it has broader carbon projects. So as you can see in the diagram, there's a legally binding limit for CCM. However, for VCM, there's no limit. You can trade as much carbon dioxide or carbon credits as you want. Yep. A brief overview as well of the market sizes for both. So as you can see, CCM is bigger. It's the majority of what is traded in the market right now. However, the VCM has so much potential given that it has no limitations. And as you can see in the 5-year period, it has a growth rate of 126% compared to 105% from CCM. So what are the activity types? The 3 types of carbon credits are reductions, avoidance, and removals. Now, as you know, this presentation will be focused more on removals, but it is also important to distinguish between the 3. So reduction and avoidance means reducing and avoiding. So this means renewable energy, using cook stoves, for example. Like Indonesia, we're doing a lot of forest conservation, avoiding damage through our ecosystems. We are conserving mangroves and so on and so forth. And that takes up about 86% of credit retired. So yes, it's easier, obviously, to reduce and avoid instead of removing. But what is carbon dioxide removal? This is a basic difference between reduction and avoidance versus CDR. They are very important. They are equally important and vital. So countries like Germany, the UK, the US, they have different targets. They don't only have net zero targets these days, they have net negative emission target as well. So as you can see on the left-hand side, carbon offset does not, it's incompatible with net zero goals because it does not remove any carbon dioxide. So it creates carbon neutrality, but it doesn't have additionality. On the one hand, CDR are removal credits are purchased to remove emissions, and the current level of emissions from CDR is thus reduced to zero. So this, again, has additionality, and the emitted CO2 is removed from the atmosphere. Yep. I tried to collate the main CDR methods. So the top 5 currently are DECS, or direct air capture, carbon storage, given the nascent stage of CDR. And if you haven't heard about DECS, this is like a giant vacuum cleaner, basically sucking carbon dioxide from the atmosphere. Just imagine that. And the biggest plants are actually in Iceland by Climeworks. Very, very cool. Feel free to Google them. But yeah, DECS technically removes CO2 directly from the air. And then we also have BECS, or bikers. These are bioenergy with carbon capture and storage. We also have AFOLU. I made it light green because it's the most common one. So AFOLU is agriculture, forestry, and other land uses. Compared to all, this is the most common and easy ones and have been taking the majority of carbon dioxide removal projects. And compared to biochar and solar carbon sequestration, for example, it is pretty much nascent. So 1, 2, 4, 5 are nascent. Number 3 is pretty much very common. And then we have the blue carbon as well, or ocean alkalinization. And in the bottom of the page, you can also see the different storage types. It can be in geological formations, vegetations, minerals, or marine sediments in the ocean, and so on and so forth. They also have different types of permanence. So permanence / durability, or as we say it in the carbon market, means the period of time that carbon is sequestered and stored without giving withdrawal impacts. Yeah, so why are we even talking about carbon dioxide removal? As I've said before, a lot of countries, especially in Europe, they are pivoting not only to net zero, but also net negative, because Paris Agreement has again been renewed. It has been emphasized in a lot of reports. And this specific diagram is taken from the State of CDR 2nd edition report by a group of researchers from Oxford University. As you can see, we are way, way behind. We need to reduce about 7 to 9 billion tons every year of carbon dioxide equivalent. However, we are only removing 2 billion tons. And yeah, if you look at the graph, the yellow lines, the yellow areas, they are net negative. And if we are aiming to reach net zero, demand reduction is not enough. Renewables only is not enough. When we are talking about carbon removal, then we are able to achieve not only net zero, but net negative. So let's zoom into Indonesia, our country, for local context. We do aim to reduce GHG emissions by 43% by 2030 and achieve net zero by 2060. This is actually highly and critically insufficient. Based on Climate Action Tracker, we are way, way behind with our NDC target as well as the Paris Agreement target. To contrast, for between Indonesia and global targets, these are the critical gaps that we need to think about constantly. Global net zero target is 2050. We are 10 years behind. We're 1 decade behind. And if we keep this trajectory, we are going to exceed 1.5, even go up to 4 degrees Celsius. Now that we know the urgency, have gone through the pessimistic stuff, let's zoom into what we have done and how the CDR landscape is in Indonesia. 2013, of course, we have the RMU, or Rimba Makmur Utama, one of the biggest players in AFOLU and as well as in Indonesia as well. So this, for example, is the Katingan Mentaya project that is launched in 2013. Next, we have the B4SS Biochar project initiated by GEF and GI and UNEP. This is a brilliant initiative from them. However, there is no follow-up whatsoever. So I've been studying their evaluation report as to why they stopped the project. This project was based in NTT as well as Lampung. And so there's an image of the, not pyrolysis, well, it's a kiln. Kiln is a more traditional form to create biochar. And yeah, 2019, we see more growth in blue carbon, exploring mangroves. We then have carbon ethics. 2021, breakthrough for biochar. We have Sawa Eco Solutions. They are one of the biggest player and the only one actually that is operational right now in Indonesia. So Sawa is founded by Phil. Phil has been here his whole life, but Sawa is actually based in Singapore. And if you look at the picture, there's Sawa's logo, and then on the left-hand side is Puro. Puro Earth is one of the most credible carbon registry in the global carbon market. And the fact that Sawa is recognized in Puro, it means their biochar credits are highly of high integrity. And we can learn so much from Sawa. So this is a great start for biochar. 2023, of course, we've seen regulation number 2 of 2023 on CCS and CCUS issued. And just this year, there's another company called Pyro CCS that are launching the projects, fundraising, and also the presidential regulation. Now let's zoom in even deeper to what biochar really is. Given that it's still in its nascent stage, biochar is gaining more momentum. Again, it's relatively new in Indonesia. But biochar is a carbon-rich material produced by heating organic matter under low or no oxygen conditions. So if you look back to the previous image here, the kiln, that is trying to achieve the low to non-oxygen condition. And yes, the pyrolysis process here is basically going through the reactor. It does not only produce biochar, it can also produce bio-oil and synthetic gas. The benefits, no doubt, 83% GHG emission reduction, carbon sequestration, and crop yield increase. So I have studied 3 to 5 papers that specifically studied this and its impact. For example, the different types of biomass agriculture resources and how much they sequester carbon and so on and so forth. Yeah. As for local context and Indonesia's biomass and biochar potential, we approximately have 130 million tons of biomass potential per year, and Indonesia has about 4 million tons of biochar potential. This is based on the assumption of 10% that could be diverted to biochar production, and because biochar yield varies around 35% of the original biomass by weight, we can say, yeah, it's approximately 4 million tons. And on the right-hand side, you can see a pie chart that is consisted of examples that we can use for input, so rice residues, coconut residues, palm oil residues, sugar, rubber wood, and so on and so forth. And jumping into the policy proposal, I'm proposing BSAC, or Biochar for Sustainable Agriculture and Climate Program. This program basically aims to foster the adoption of biochar in Indonesia agriculture to not only achieve climate goals, but also address waste management and improve farmer prosperity, because we are also touching upon their economy, their crop yields, right? Now, starting with reallocation of 7% from our current fertilizer subsidy budget. This is roughly around $130 million. Of the 2 trillion for fertilizer subsidies. And throughout this budget, we are going to give to farmer adoption incentives, research grants. So this is one of the most important ones because R&D is crucial in the carbon market, training and education as well, and production subsidies. The expected outcome, as I estimated, could be, first, of course, waste management. Up to 4 million tons of agricultural waste can be turned into biochar. 10 to 15% waste burning can be reduced, and utilization of various agricultural residues, like in the pie chart before, can be utilized. As well as climate goals, we can sequester up to 900,000 tons of CO2 equivalent annually. We are obviously also contributing to Indonesia's NDC targets, and we have gradual reduction in chemical fertilizer dependency. We have also the potential for additional income through biochar production, and lastly, economic development, as we can potentially create up to 5,000 new jobs in the industry and establish Indonesia as a biochar player. The policy framework will be integrated into existing agricultural policies and leverage private sector expertise. We've talked about Sawa Eco Solution. We've talked about new projects coming in like PyroCCS. There's also Nutra from Germany. Now, these are the crucial part of the framework. We are aligning with the RPJMN, or the National Medium-Term Development for 2020 to 2024. We're also complementing the existing fertilizer subsidy program. So instead of going head-to-head with the subsidy program, we are complementing it, reducing the use of chemical fertilizer gradually. We are also supporting DAP Pertanian, or the objectives for the Agriculture Special Allocation Fund. And as I've emphasized time and time again, we are facilitating this public-private partnerships with established biochar companies to leverage their not only expertise, but also the facility that they've already established. So the program structure will be 2 pillars: public-private partnership and the government support. On the left-hand side, we're looking at biochar production support from these partnerships, farmer education program as well. So to look deeper, government can co-finance up to 40% of facility costs, capped at 10 billion rupiah per facility. We are also looking at 5 million rupiah per farmer for small-scale units, which is the majority of farmers. Based on my research, majority of Indonesian farmers have less than 1 hectare of land. And also the education program, we are establishing biochar livelihood schools to train these local farmers. Based on the B4SS evaluation report in NTT and Lampung, it is highly important to not only educate them, but ensure that there's social acceptance and also commitment for them to learn. Next is the government support. We are branching into farmer adoption subsidy and soil health support. This means 50% subsidy on biochar price, up to 2 tons per hectare. There's also additional 1 million rupiah per hectare for small farmers, and then another 3 million rupiah for implementing recommended soil health practice via a soil health card system. Now, this system is adopted based on India's system. The reason why I had comparative analysis between Indonesia and India is because we have very similar outlook, very similar geographical conditions as well. And our target market, players here are small and marginal farmers, which India has been able to include in this organic farming initiative. So the carbon credit incentive as well guarantees government purchase. This means we are trying to advocate for government procurement, and then up to 30% of credits at a floor price of $15 per ton for CO2 equivalent. So the implementation timeline will have 3 phases of phased implementation. The first one, being the most crucial, is year 1 to 3. We are focusing on 5 pilot provinces to target 10% of cultivable land. Now, these lists are selected based on strategic importance in Indonesia's development and its agricultural diversity and distinct challenges. So, for example, in West Java, that makes sense. It's not only close to Jakarta with resources, for example, or Sawa, they are developing another facility in Bandung. IKN, we are moving capital cities. That makes so much sense for us to explore as well. In Kalimantan has so much biochar potential. And yeah, jumping into phase 1 mechanism as well, we can establish a national registry for biochar carbon credits to be part of the IDCX. And then we can put together a public-private steering committee with representatives from relevant ministries and biochar companies to, again, leverage their infrastructure, their knowledge, their experience in the market. We can also develop standards for project approval and MRV. MRV here stands for monitoring, registration, and verification, which I will elaborate in the next slide. And lastly is to create regional centers for initial biochar production and distribution. I put initial in bold because it is very important to drive initial demand and initial supply to also see how the market traction goes. Yes, so this is all about MRV and certification mechanism. It is recommended to have a hybrid approach that combines both international standards with locally developed methodologies. Now, it is very vital to ensure that we have credibility for the global market. So international standards, for example, the International Biochar Initiative, or IBI, they are very much recognized for solid foundation for biochar quality. We also have the EBC, so it's up to the government, whichever they choose. We can also have local adaptation. For example, we are actually aligning with Indonesia's plan to develop its own MRV standards. So if you're an industry expert in the carbon market, you probably know that Indonesia is making a national carbon body, a badan, for this and also includes the MRV standards of their own. So we can develop Indonesia-specific standards based on these international frameworks or tailor it specifically to our own local context. And lastly is regarding the certification system. We can implement a PGS or participatory guarantee system that is similar to India's PKVY program, basically. This system is very much farmer-centric. It means these small players don't have to pay to be certified because, again, they don't have the resources to do that. They can't pay for it. So the systems allow for smaller stakeholders' involvement. Zooming into more of the MRV system, I've mentioned that it will be a hybrid approach. And yes, I think it's also important to bring in private MRV companies such as Fair Atmos, for example, from Indonesia. It's one of the most well-known one. And they for sure have experience in MRV, so we can also bring them to, for example, help us with regular soil testing, tracking the biochar application rates, with the reporting, as well as the verification. Yep, moving on to certification system. I've mentioned briefly about the PGS. This is a breakdown of what PGS does, basically. So in India, they are doing farmer groups that peer review one another, give documentations, basically analyze each other's eligibility for the carbon certifications, and the decisions are made collectively. I've spoken with people from the IBBN, or the India Biochar and Bioresources Network, and it has been feasible and work in India, targeting marginal and small farmers. The challenges, of course, you might be asking, but what if it's not credible? What if they are doing it out of the standards? Now, yes, that means we are pushing and strengthening training and community monitoring. We are also implementing external audits, clear standards, and also enhanced transparency while utilizing technology. Again, this phase 1, is very much important to establish that sense of ownership as well for our farmers. Yeah, so for next steps, it's to establish a multi-stakeholder task force, a comprehensive, well-planned one that allows for a detailed breakdown to finalize program details, implementation strategy, and develop the PGS, especially given that it's the most important MRV mechanism. And then launch public-private partnership initiatives to initiate discussions with biochar manufacturers, agriculture input suppliers, so basically the main producers, main distributors. How are we going to upscale? The third one is to conduct pilot projects with industry collaboration. So pilot projects are highly important because we need to pivot just in case anything works out or anything doesn't, to ensure our scalability is also efficient. And lastly is to develop robust MRV and certification mechanisms. This means choosing whether international standards or using our own local context for MRV. This stage ensures high integrity credits. So to conclude, Indonesia is falling behind in adhering to global climate goals, particularly due to the insufficient trajectory for reduction and removals. However, its biochar potential can be a solution while fostering a more sustainable agriculture practice and economic growth. So we've seen how much we actually need CDR and the potential of our biochar here. A lot of companies and investments from many countries are coming in to look at our biochar potential as well. So why not start now? So why not the government ensure that we are already accelerating it before we wait for more and more investment to come. And given that the fertilizer subsidies is also dominated by the government, I think it's a brilliant solution that we gradually transition to also have the use of biochar. And the second, the BSEC program addresses key challenges in soil health, waste management, and climate change mitigation. It also balances both large-scale infrastructure development with support for smallholder farmers. It leverages public-private partnerships and international best practices. It is crucial, as I've mentioned before, to establish initial market demand and supply chains. Now, in carbon markets, all policies should drive demand. Lastly, with proper implementation, this BSEC program has the potential to transform Indonesian agriculture and to contribute to global climate efforts. So yeah, that is all for my presentation. Feel free to connect with me if you have any questions. I also post a lot of blogs regarding carbon dioxide removal in my Medium. So yeah, the floor is back to the moderator.
All right, thank you so much for the interesting and insightful presentations, Miss Cynthia. Yeah, that is really insightful for me personally. All right, so we are now in our discussion sessions for approximately 20 minutes. So maybe I will check if there is any questions from the floor, but maybe to begin our discussions, it will begin with my questions first. Okay, so you were talking about carbon reductions, avoidance, and then removals. In your opinion, which of the actions that is more urgent for Indonesia to adopt? Maybe that is my first questions.
Yes, thank you so much for the question. I think I've touched upon that all of them are equally important, and a lot of Western countries have different targets. They have reduction targets. They also have having the removal targets, right? But in terms of urgency, definitely carbon dioxide removal. We are doing a lot, yes, in renewables, in our energy transition, for example. But again, we've seen the local context contrasted to the global target, for example. We are way, way behind. And yeah, I think we can always learn from what the European countries are doing, especially, or even India, for example, or neighboring country, right? On the removal targets. India, for example, they don't necessarily publish, the government doesn't publish that they have CDR targets, but they are already doing it. So I think that's something we should follow. Yeah.
All right, thank you so much. Also, I have other things that I think it is also interesting because you were also talking about several technologies regarding CCS, right? Including DEX, if I'm not mistaken, direct air capture, blah, blah, blah. Yeah. So maybe I would like to know, is it already applied in the UK? Are you now in the UK or are you now in Indonesia?
Yes, I'm based in the UK. But for DEX, the biggest one is actually in Iceland. So they're given their regional and geographic location, it's very supportive for them. In the UK, we are trying to still explore on that, but we do have a BECCS plant. And if we're talking about European countries, Germany is doing more compared to the UK, for example, because the UK, we can't do much about CDR, but what we can do is, for example, promote RNA and also the policies, be present in the dialogue, right? But yeah, the biggest one is in Iceland for direct air capture, and not sure if it's feasible in Indonesia for now.
Yeah, that is actually my my questions. Do you think is it suitable for Jakarta? I mean, we all know that Jakarta is one of the highest air pollution city in the world. Yeah.
Yeah, I generally think we can leverage so much more of the nature-based solutions, such as like today I'm talking about biochar. A lot of companies are also exploring sargassum, so blue carbon. Sargassum is brown seaweed, and given our geographic location, I think it's best to explore that and leverage that. And direct air capture is highly, highly expensive, so that's a lot of work. We have not any haven't done any feasibility studies whatsoever. We have, I think recently Pertamina is doing exploration for BECCS. So yeah, I think DEX is pretty behind. We're far from that. Yeah.
Okay, so here I see there is a questions from the audience. It is the questions from Ardia Dennis. So great presentations. Yeah, can you explain more about the regional hub center and how do you think that would work?
Yes, thank you so much for the brilliant question. So the regional hub center, as I've mentioned before, will initially help drive demand and supply to, for example, in West Java, we will have one. In IKN, we will have one. This means we have a more controlled biochar production as well. But then this is only temporary, so this is only in phase one. We gradually obviously want more players in the market, so regional hubs would only be centralized for a short period. Well, not short, but like at least for the phase one, so year 1, 2, 3. Yeah, and gradually we will ensure that it's decentralized.
I see. So I hope that answered the questions from Ardia Danis. Yeah. So maybe let's start talk about biochar. So can you explain more or elaborate more what is actually biochar is?
Yes, I can maybe reshare my screen to the slide. There you go. Yes, so biochar is a carbon-rich material produced by heating organic matter under low or no oxygen conditions. So these can sequester carbon up to, well, it's still debated, but it's from decades all the way to centuries. And the uses are not only sequestering carbon, it's also very useful for farming, right? As you can see here, it can boost crop yield between 10% to 40% due to its sponge-like structure that increases water absorption. This crop yield increase also results in biochar becoming a valuable asset because I think there's this one study from 2012 or about 2015 where farmers create their own traditional kilns, like the one shown here in under the 2018 timeline. So farmers have explored that in the past in Asia, but it's just gaining momentum now because investors are coming in because carbon dioxide removal is getting more and more significant. So yeah. Hope that answers the question.
Okay, thank you. Okay, so yeah, if I'm not mistaken, you also mentioned several biomass in your slide.
Yes.
Maybe in your opinion, which of the biomass that is most interesting to develop in Indonesia to be a biochar? And can we synergize the productions of biochar with other production? I mean, maybe palm oil.
Yes, so given our geographic location and the rice potential that we have in our agriculture, rice residues can take up the majority of it. And there's a lot of studies that rice residues or husks can boost by 40% of biochar of crop yields. Apologies. Yes. In terms of palm oil, I think that requires further research, and I'm not too sure how it goes hand in hand, but at the same time, it definitely goes hand in hand with, again, waste management. It goes hand in hand with increasing crop yields. This means farmers does not only play a part in sequestering carbon, they also play a part in the market and also have more economic advantage. For example, like Sawa Eco Solutions, they are obviously selling the carbon credits internationally, but they also sell biochar in like packages. So they are in the form of they're like solid packages that you can apply like fertilizers or soil enhancers. So yes, there's a lot of potential for our farmers if they join into the the biochar production for even more revenue as well.
Okay, thank you. So interesting. So I would like also to know about maybe is there any sustainability standards that should be implemented in producing biochar to produce that it is environmentally friendly?
Yes, for sure, for sure. That's one of the reasons why I spoke with Phil, the CEO of Sawa Eco Solutions, because me myself, I was exposed to the carbon market and carbon removals for only 2 months, right, during my internship. So there's so much to learn from Phil's side as well, from how he gets the recognition from one of the most high credible carbon registry, for example. So yes, for sure, there's starting from the production process, starting from the distribution, and all the way when it's issued. These credits have for sure standards. Like I've mentioned before, it's up to the government if they are adopting the BSAC program, whether they want to use international standards or adapt the local context. But again, I've mentioned that it's important to just have a hybrid approach because credibility is very hard to achieve. It's one of the biggest problems in the carbon market, actually, on trust and getting trust signals. Ensuring that it's high integrity carbon. High integrity means, again, all the processes are sustainable, is standardized, but at the same time does not cause withdrawals. So withdrawals means the carbon goes back to the atmosphere after it's been locked away, right? So yeah, I think it makes so much sense for Indonesia to develop its MRV standards, but at the same time, credibility must be emphasized. So definitely look at Sawa's expertise, for example, or Fair Atmos throughout their experience in MRV.
What about the certifications you mentioned in your slide? Is it different with the MRV?
Yes, so the certification certification is a part of verification. So MRV certification is a part of MRV. And what I'm suggesting here is instead of buying the certifications, because it's very expensive, and we want it to reach the scale of local farmers, small farmers. We don't have the resources for that. The farmers don't have the resources for that. So I think it's best to implement what India is implementing called the PGS. Yeah, I think it makes so much sense, but there's so much work in the beginning to ensure that these farmers are aware of what they're doing. They want to participate. Yeah, so a lot of work.
Whatever. Okay. Yeah, I see. Okay, so there is another questions from the audience. Here is the questions from Lulu Intan from Fatmawati. So I have heard that biochar is also eligible for carbon credits. Could you explain more about its current practice and whether it is considered better than carbon credits from nature-based solutions? Yeah.
All right. Yes, thank you so much for the question. Let me share my screen because I have some appendix slides as well. Okay. So we have the biochar price per tons. This is weekly projection from Allied Offsets, the company I interned in, actually. Brilliant insights. So as you can see here, the prices always fluctuate. They are obviously eligible for credits, yes. But the hard work that will come from the government is to ensure the stabilization of the prices, right? It's tough to firstly make a registry, a carbon registry for biochar, and then register it to ICDX carbon, for example. And it's another job to ensure that the prices don't fluctuate and it's still affordable. Hence, that's why I think it's best, again, to go back to the program structure that I've mentioned is for government procurement to ensure that, the farmers are producing X amount of credits per month, per year, for example. And they are guaranteed that these will be purchased because government will procure them. The government will purchase them, and the government can do this by either directly purchasing them or signing partnerships, for example, in the international market with any corporations who would like to buy the credits from us. So yeah, I think that's how we can try to regulate it.
Okay, thank you so much for the explanations. I hope that answered the questions from Lulu. Okay, so here is another questions from me, maybe because I find it really interesting.
Yeah.
In your slides, you also explain several steps that we need to do. And I see that you mentioned that we need to create the multi-stakeholder task force. Could you identify which institutions or who are the multi-stakeholders task force for the
Yes.
implementations of this?
Yes, of course. So if we go back to the policy framework slide, wait, sorry, can you see my slide? Let me
Not yet.
share.
Yeah.
There you go. Yes. So of course, the Indonesian Carbon Exchange, we need the market to also be supportive, and the biochar registry to be registered. We have Asosiasi Biochar Indonesia International. This is one of the most pioneering movement for biochar. They work with a lot of corporations. SAWA is actually a part of it. Phil is one of the co-founders, along with other well-known businessmen or business individuals, as well as professors in the industry as well. So Asosiasi Biochar will definitely play a part in helping us train and educate. They are already doing it to several corporations as well. And yeah, I've also mentioned the Badan, the new national carbon body under Prabowo's new not regime, yeah, new elected president will create the national carbon body. And I think this restructuring will mean a lot of new players. And so I'm not too sure whether the Ministry of Forestry will be restructured as well, but hopefully we stick to, for example, the initiatives to not only develop CCS, CCUS, but further talk about CDR more. And of course, the private sectors such as Pyro CCS, not only SAWA. As time passes, we are sure that there's going to be more and more biochar facilities in Indonesia. We're also talking about the MRV players such as Fair Atmos. Pachama is one of the most famous ones. They're international, so they're based in the US, but they're one of the most credible with their MRV systems. And they work with several Indonesian projects as well. We also have True Climate, I think, one of the newest ones. So yeah, I think in terms of stakeholders, it's very much important to also tackle these producers, especially local farmers, right? So if I go to my appendix, I've done a table as well to analyze those in India. So we're looking at producers, raw material suppliers, manufacturers, and technology solution providers, right? In India, these companies like Arsta, Anand, Farm to Energy, they're the ones who produce the biochar. And then there's another company that sources these biomass feedstock for biochar production. So that's another business opportunities if you're entrepreneurs in this space looking for climate tech or be involved in sustainable development. You can create your own company as a raw material supplier. So this means from timber industries, forestry, municipal bodies, right? And the manufacturers, this means companies that can produce the equipment that have the pyrolysis reactors, such as Sawa. And the technology solution providers, this means institutions that cannot conduct R&D or research and development. We will need a lot of help as well from universities. I think as for renewable energy, we already have a lot of youth movement, right? For example, SRE in Pertamina University now. Universities can also work with this program, for example, when they are more keen to develop and research biochar. For sure, we are encouraging institutions like that for R&D to help the government as well. So not only public and private, but also institutions like universities. I hope it answers the question.
Okay, thank you so much for the explanations. Yeah, I agree with that. To boost the implementations, we need to create the system, the ecosystem, right?
Yes.
Okay, so here is another question from Ardia Dennis. The question is, looking back to your strategy and framework, are there any cost-benefit analysis? And what about the risk for implementing your proposal?
Yes, thank you so much for the question. Let me again share my screen for the risks. Yes. This should answer your question because I've outlined and researched a lot of risks here. But the first one, of course, is the inconsistent biochar quality. So in tackling this, we can implement strict quality control measures through the PGS. As I've mentioned before, we need also the centralized regional hubs to ensure these quality are monitored. If we are pivoting, for example, we can control them, monitor them. The second one is obviously the unsustainable feedstock sourcing, like Kak Rahayu's question before. Sure, we can develop guidelines for sustainable feedstock management, but then again, it needs to be very, very strict. We need to ensure that all the standards are consistent, but also flexible. We need to encourage the use of agricultural waste and avoid competition with food production as well. And yeah, the next is market distortions due to subsidies. For example, we can then design a phased subsidy reduction plan as the market matures. I've mentioned before that we are not going against head-to-head with Pupuk Indonesia, for example. We are complementing. We're trying to complement the entire system. And yeah, we are also encouraging private sector investment to reduce the reliance on government subsidies in the long term. And lastly, the conflict with existing fertilizer subsidy programs, I've touched upon that. We can talk as well about the lack of long-term research and data specific to Indonesian conditions. This is one of the most, this is one big problem as well, because we are very early and new to the market. So we need to establish partnerships with universities and research institutions, like I've touched upon before. We need to allocate funds for long-term field trials. We can also create a centralized database to collect and analyze all these biochar application results. And I think this could be helped so much by Asosiasi Biochar International, because they are already doing it anyways. And then we can also see the uneven regional implementation due to varying local conditions. So we need to develop region-specific implementation plans. We've seen the 5 early provinces. For sure, their agricultural conditions are different with one another. So we need to ensure flexibility as well in our policy guidelines. And lastly, the carbon credit market volatility. I think this is also something to think about. We need to diversify the revenue streams beyond carbon credits. I've mentioned Sawa is also selling them in packages, for example. And yeah, we need to establish a government-backed minimum price for biochar-related carbon credits through procurements that is possible, and as well as develop partnerships with international carbon credit buyers.
All right, thank you so much for the comprehensive explanations, and I hope that answered the questions from Ardia Dennis. So, okay, because we have only 30 seconds left, you may have your closing statement before we close the discussion sessions.
Yeah, thank you so much again for having me here, and thank you for moderating, and thank you everyone for the brilliant questions. I hope the BSAC program is useful just to push everyone to think about CDR even more. And yeah, feel free to reach out to me. Thank you.
All right, thank you so much, Miss Cynthia Jayaputra, for the interesting and insightful discussion. Yeah, I hope we can see each other again on another occasions. And I would also like to remind you that we have an ongoing nominations polling with several categories such as the most engaging, the most impactful, the most visible, the most collaborative, and also the most visionary and the most community-centric. So you may invite your friends to fill in the polling so you can win the nominations. Okay, hopefully our discussions not only ends in this room, and the insights of policy proposal for accelerating carbon removal in Indonesia can further boost the sustainable green transformations, particularly in decarbonizations. Thank you so much, Miss Cynthia, and I hope we can see each other again. And also, I will also close our discussions here because the following agenda will be moderated by Miss Sabrina Farah Salsabila from the CEO at Reservoir. And all right, thank you very much for your presence and participations, and for any inconvenience or shortcomings you may have experienced, please accept my sincere apologies. All right, thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, and to all the participants. And I'm hoping that you are in a good health. And it is a pleasure to meet you at this event. Welcome again to the Indonesia Sustainability Forum's virtual academic dialogue, which is a part of Indonesia International Sustainability Forum 2024. And I guess my session will be the last session for this virtual academic dialogue. Let me first briefly introduce myself. My name is Sasa from Reservoir, and I will be your host for this session. Yeah, this is a short description about myself, and I just graduated from the Netherlands to study in IHE Delft, and I'm also currently developing my social enterprise called Reservoir, which focus on sustainable water management, and also I'm part of Nufix Southeast Asia as a water support expert officer. So, today we will be listening research from three talented students. Each student will present approximately 40 minutes, and we will it will be followed by 20 minutes for the question and answers. So we already have one student here, Mbak Priscilia Fibriani from King's College London will present her research titled Biochar Subsidies, a policy proposal for accelerating carbon removal in Indonesia. How are you, Mbak Priscilia?
Halo, Mbak Sabrina.
Yes,
Suara saya
okay.
terdengar nggak ya?
Yes, I can hear you very well.
Oke, ya.
And
Yeah.
okay, so you will have maximum 40 minutes of presentations, and then we will follow by question and answer. I think time and floor is yours. You can start the presentation.
Okay, thank you very much for welcoming me, Mbak Sabrina, and thank you very much all for your attention today. I'm very glad to be present my research in Indonesia Sustainability Forum to have an I'm Priscilla from University College London. It is I think the previous research that you mentioned is from Mbak Cynthia that present last session. So today I will present about my research in cost benefit analysis and business proposal implementing for sustainable development goals. It is the case of the sinking Jakarta. And a little bit of background. I'm a Bachelor of Architecture in Bina Nusantara and have worked for several years in Johns Lang LaSalle before doing my master. So I'm now a part of the Bartlett School of Sustainable Construction, enrolling my master in real estate economics and investment analysis. First thing first, I think I haven't shared my presentation. Let me present it for you to also see. Yeah, is everyone can see my screen?
Yes, it can be seen perfectly.
Okay, thank you very much. Okay, so yeah, I'm actually quite honored to be part of the Bartlett School of Sustainable Construction because there's a culture of disruptive thinking in our university. So we tend to approach problems with multidisciplinary approach. And I can also say that my proposal today is also not so familiar approach. And maybe it's a little bit intriguing at the first, but let's see, because I will explain on how it actually executable. So this is it. To give a little bit of context, this is my research project of 3,000 words essay for the environmental sustainability and construction sector modules. I document one problem of a city, like I pick particular city and then propose a solution on it. And then I picked Jakarta because I was born and raised there, and there's a lot of environmental problems that Jakarta still have, and I try to approach it to more sustainable real estate management and try to put and the output will address the four sustainable development goals. So this research is conducted by literature study comprising of the journals, articles, news, and the solution will be based on cost benefit analysis and business proposal basically. So it will use the net present value or NPV projection and then based on the inflation rate. So first thing first, I want to ask you guys, like, what do you think if like Jakarta has a lot of environmental and urban challenges right now? And there is actually a mitigation problem of the problem with increasing green open space and with the capital city set to relocate to Nusantara, there are a lot of state-owned assets that left underutilized. So I propose that these assets comprising of governmental office and etc. to be converted into green space. Like, what do you think? Is it a bad, good idea, or maybe you don't have any idea at all? Yeah. So let's exercise this idea. I will start with the problem first. First thing first, I would like to answer the question on how severe is the problem of Jakarta sinking. There's a lot of international and local media have criticized this, that Jakarta has notorious stigma as sinking city, and even like Bloomberg makes extreme statement that Jakarta only has until 2030 to figure out a solution. To justify, yes, Jakarta is sinking at a depressing rate. It is like 15 centimeters annually, but not only that, it is also made worse by the rise of sea level by 10 centimeters per year. So in total, it reaches like 25 centimeters annually. And on top of that, there is still a possibility of it becoming worse. And the root cause of all this is groundwater depletion and the groundwater recharge that cannot be done properly because there is no enough green space there. One of the main reason it is very hard to add more green spaces because there is no land available. And regrettably, there is yet no concrete solution at the moment to address the groundwater depletion. For 10 years ago, there's a NCICD or National Capital Integrated Coastal Development, or we also know as the Giant Seawall Project, was once planned to address these issues of coastal erosions and abrasions. And lately, it has been reconsidered by the government to extend along the coastal of North Java. But the potential expenses is huge, and there is no rainwater harvesting effect or the groundwater recharge that actually quite the core problem of this issue. So other things is there are four highly concerning issues in the that Jakarta has. This is only four, but actually there are a lot of it. But for the solutions, these issues can be addressed. So there is, if you see here on the bottom left, there's a Wal Aduna Mosque in Muara Baru, North Jakarta. It is not used to be sinking like this. It should be on land. And there's a this is a precedent of how severe Jakarta sinking actually. And this is like a hindrance for this sinking issue is actually a big hindrance for multinational company to represent themselves in risk in Jakarta because they consider that this area is risky. And the next thing, there is an interesting combinations that there is a annual flooding, while sometimes there is also drought. And in an economic perspective, it actually can impact it until 0.5% of firm's revenue. So it is quite a big amount. And Jakarta has manufacturing as one of the top GRDP or gross regional domestic product contributors. So the drought can cause the business interruption for this manufacturing. And it is quite a top contributor that it actually comprises 11% of Jakarta's GRDP. And then there's also the problem of air pollutions that is quite severe right now. For in average, it is around 70 to 150 air quality index, and it is on the band of unhealthy, especially for the sensitive groups. And this cause great expenses for health care in Jakarta. The cost can be up to 47 trillion Indonesian rupiahs. And yesterday I rechecked it once again, and yes, it is that huge. It is comprises of 30% of the national health insurance in Jakarta. So it is right. And last, there is a saturated real estate market, especially for the office sector. Jakarta right now has the second highest vacancy across Asia Pacific after Kuala Lumpur, and it is around 25% of vacancy. This is already happening for almost 10 years, and it means that the oversupply makes the price hardly go up. So it is very hard condition and make it reluctant to make a new investment coming in. And then next, I will explain about the SWOT analysis about all these concerning issues. So I will discuss it in the economic perspective. This is Jakarta's issue. And then we have the main problem of sinking because of the groundwater depletion, because there's not enough green space available, and then because it is there's not enough land, because the price is already expensive, and I see it as a weakness. And then there's also some environmental problems, annual flooding, but there's drought also sometimes, and there's a severe air pollutions. And this all becoming a business threat. It is a threat for like sustainability plan in the long term for many multinational companies. And for the air pollution, it causes health problems. And from the governmental perspective, there is a capital city relocations that cause there's a lot of underutilized assets because of this relocation. But I can see this as an opportunity. And with this, like there's a weakness, opportunity, and threat. Where's the strength? We can save it for later. I want to also remind that there's a saturated real estate market because of the high expensive land price. And since all the other environmental problems also can be helped by the presence of more green space, I come up with an idea on how if we're actually marrying the weakness and opportunity to make to utilize the underutilized asset to become more green space for Jakarta. So the question is, this is the quantifications answer. How much is actually Jakarta need green space? And right now it has less than 5%, and the target is actually more than 20%. And means that we are still lacking of 15%. And this means that we need 10,000 hectares of more green space. And if we convert this into green space per capita in the graph on the right-hand side, Jakarta only have approximately like 2 square meter per capita of green space. And even if we actually successfully achieving our target of 20%, means like multiply it into 4 times, then we're still on the very low band of green open space available. We're very far from our sophisticated neighbor, Singapore, with 66%, and even Sydney, that becoming one of the highest, is actually have the plan to add at least 40% of more green space in 2050. So yeah, Jakarta desperately need more green space. And then I will explain the benefits, like how effective is actually providing green space for Jakarta. We refer back to the 4 issues that we want to address. There's a benefit on groundwater recharge if we have more green space, because there's a ratio of 1 compares to 2. So every 1 square meters of green space, there will be 2 meter cubic of rainwater can be absorbed per year. So if we convert it into flooding mitigation, it actually can covers like it can free 60% of Jakarta's area of 50 centimeters flooding. So it helps a lot. It can mean like more than 30 districts. So if we're talking about like air pollutions, there's one particular element in air pollution that is very harmful. It is PM 2.5. Jakarta have more than 2%, 2 or 3 times more than what is standardized by the WHO. And it is actually need some kind of we need to address this before the air pollution become more worse, because it causes a lot of health problems. It costs a lot of costs to cover those health problems. And with having 20% area covered by this green space, it actually can reduce up to 25% of it. And remember that there's a saturated real estate market. There's a potential for real estate market catalyst, because there's more allocation to the green space, means there is a less space available, so we can keep the supply, and with the supply is kept on certain number, there's no oversupply, and then the price can grow. And we also know that having a nice green space, it can improve our neighborhood. So it is actually potential for the areas that have not really good quality to actually can improve themselves. And with this all, actually we can address at least 4 SDGs, the 11, 13, 3, and 6. And then I will discuss about like the technicalities of this solution, like how it is actually can be visible. There's an opportunity of the relocation from Jakarta to Nusantara. It has it caused great dynamics, and particularly in regard to the state-owned asset that was once used and then will gradually become vacant. And Finance Ministry indicate that the total value of assets is around 100 billion US dollar. Like this is more than 1,500 Indonesian rupiah. This amount of asset is the value that I propose to be converted as green space. And this amount is very huge, but I want us to see from a cost and benefit perspective. If we compare it to the amount of GRDP that reflects the productivity level of Jakarta. Compared to Jakarta's latest GRDP, this amount is around 45%, and it means that Jakarta can produce the same amount of total value of more than what it costs in only 6 months. And it also means that the productivity of Jakarta can double the total of state-owned assets in 1 year. I know it's not really part to part, but this is like just a quick comparison on how precious Jakarta is. This is a economic powerhouse that we have to protect. So with this high potential, we want to see Jakarta sinking and seen as a high risk area and then maybe losing its potential for more business, or do we want to improve Jakarta to be more resilient and then can create a higher productivity and to attract more investment? So remember that there's a SWOT analysis and we're still missing the S. So actually the S is lies in the Ministry of Finance as a key stakeholder on all this, because Ministry of Finance have a great power of, from the real estate perspective, they have a property possessions and also they're in charge of the asset management, but also in charge of the state budgeting, of course. So the Ministry of Finance have strategized the plan for mitigating this, to overcome this underutilized assets, and there are at least 3 goals that they want to achieve. It is to enhance the non-tax revenue, reduce operational costs, and then support the financing of new capital of IKN. So this we should put in mind of all these 3 strategy of Ministry of Finance, and then we will try to calculate all the value. This is the value calculations. I try to put everything on the table. The potential we have, what are the problems, and how much it is actually cost. So let's recognize all of these elements. In this case, I want to emphasize that we want to rationalize all this feasibility. From the state-owned assets, there is a 70%, if we say repurpose the 70% to be utilized, we can actually have 1,000 of trillion rupiahs, because there's 21% that needs to be repurposed for internal use, and then there's a 9% that we want to allocate for an income generating asset for financing the new capital of Nusantara. And if, say, the investment return is around 10% per annum, we can actually finance all the expenses of Nusantara in 36 years period. But we know that this is not the main funding. There's also other source of funding, so this period actually can be shortened. And then if we see this number of 70%, maybe it will be quite similar to the new giant seawall project. And then we also have to realize that the health impact, because there's air pollution is very huge, as I mentioned before. I sum it up to 10 years, and this amount is actually comparable to the new Nusantara project. Yeah, it is very huge, and if we didn't do anything about the air pollution and stuff, the health problems will rise. There's more expenses, and it's not only the expenses, but it's also there's a cost of death of some residents. And there's also impact of flooding. This is quite small, actually, although have been somewhat to 20 years, but potentially there are a lot of actually business interruption loss that unprecedented. There's also like maybe cancellation of potential investment, and then productivity decrease, and there's also health problems and cost of death of Jakarta resident again, like that can make occur every time every severe flooding happen. So with all those value, it might not be wise if we only see from the financial perspective, but actually there are a lot of value that is not precedented. So this is the proposed solutions. We acknowledge now that Jakarta needs at least 15% of it to be converted as green space. It is 10,000 hectares. But we know that the land price in Jakarta spread in a very wide range. So the Jakarta's in the central Jakarta, the price is extremely expensive, while the area near perimeter is still more affordable. So in this right-hand side graph, there is the x-axis covering the land price, and then y-axis is actually covering the area that we can have. So although it is a very high level indication, but the message is clear that with the cheaper land price, we can get more green space. And understanding this dynamics, that is maybe better to have this proposed scheme of swapping assets. So state-owned assets are located in a strategic locations and have a significantly higher value, while there's maybe partners in private or non-governmental institutions that have other places, other area in still in Jakarta, but have a larger land area overall. And we can do a asset swap with the leasehold status. Why leasehold? Because state needs to have the perpetual ownership to the land. And with this scheme, we hope that we can get a decentralized green area and with a larger space, while the more strategic asset can be commercially used, repurposed, and becoming a business potential for the private and other interested party. So this is a very high level scheme, and we want to break it down into achievable steps. Right here, there's a practical framework to be done. First thing first, we have to recognize the value of each asset. Of course, landmark assets cannot be swapped, like Istana Negara, Sekretariat Negara, Monas. There's a lot of properties that also have heritage status that have to be preserved, but there are maybe some of them that actually more flexible. And for the valuation of the asset, it should be on the perspective of the upcoming function, not from the perspective of current use, so that we can achieve the better value. And then next we go to the bidding phase. Well, the private and other non-governmental institutions can offer their assets. There's a scoring and partner selections that have to be done in a transparent way, and also like it has to be a good deal for both parties. And then the design and construction, it is a very vital part, I can say, because with a thoughtful design, the effectiveness of environmental benefit can significantly increase. And for example, selecting the vegetations that have a highest CO2 absorbing capability, and also like really maintaining the proportion of trees rather than just grassland. And last but not least, there's important to have a smart property management in terms of legal aspect, because there's a leasehold status, we have to maintain the tenure, and then there's a practical aspect to make sure that there is no informal settlement, there's a decent safety and security level in those green park. And then last but not least, I want to explain about the stakeholder interest right here. There's a public interest, government interest that need to strategize the asset utilization, and the solution actually can be one of the answer. And it can also approach the target of green space. And then from the private perspective, we know that this can be a new business opportunity for private. And then there's a solution for inert asset, because sometimes developers have certain land that is hard to be developed, and it is very long to wait for the market to actually going well. So with this swap of asset, hopefully that the private can get a more strategic locations asset that is more easy for them to develop a new business there. And because this involves a very big change from the perspective of users, is it can open up more job opportunities for valuers, for architects, for the construction workers. So it is a very big business. And overall, in the user level, it can increase the urban neighborhood quality. It can address the health problems and mitigate the expenses because of that. So yeah, this overall can justify each stakeholder interest. And this is maybe a little bit of reflection. I'm inspired by the book of Ilan Kelman that says that actually disaster is not a result from natural hazard themselves, but it is more to the inability of us to manage, like the human choices. There are like social, political, economic decisions that has to be more strategic, and then there's an environmental neglect, inequality, and poor planning that can turn this hazard into catastrophes. And actually, if we're talking about the catastrophes, maybe it's not happening like instantly, but it is accumulations of our decisions. And more on top of that, it is actually a huge potential for us to capitalize these environmental challenges into an impactful business. Yeah, will be a big business. I would like to thank you for all the resources that I cited here, because it's immensely helpful for creation of this proposal. And this all of my presentation. Thank you very much for your attention. Let's connect on LinkedIn.
Thank you so much, Mbak Priscilia. It's such an interesting topics and also research. So we already have some questions, but maybe I will little bit highlight some points that I find it very interesting. You also started the presentation with questions. I wanted to answer that actually. The IKN and also the Jakarta case.
Sure.
And also, Mbak Priscilia emphasized some main problems in Jakarta, which I would say yes, Jakarta has so many problems which also interlinkage with one another. And you use the SWOT approach first to make us understand better about those interlinkages. We already have some question here. We have from Pak Arif. He asks about what we need to stop and after a sinking Jakarta disaster when we do not have the finance, when we have the money, I think, yeah. So in your perspective, with your research, what can we do if in case we don't have the money to stop the sinking case of Jakarta?
Okay. Yeah, thank you very much for the question, Pak Arif. Yeah, actually, money in general is the main problem. Yeah, that's why we have to see it from other perspective. Like maybe we can leverage money from other sources. And I actually I want to propose that to address the green space issue, to address the sinking issue, we need groundwater replenishment, and the groundwater replenishment is very much related to the rainwater harvesting in land. And this is actually need green space, and the green space is it's not only money problems, but also an area problem in Jakarta. And with this scarcity of land, we need another land to be converted into green space. And with this capital city relocation, there's actually a lot of state-owned assets that located in Jakarta, and then they actually haven't got any function like any specific function yet. And this is actually a very huge potential to be converted into value. And this value is bring money, and this money is can be converted into potential to actually answer the problem of the sinking Jakarta. So it's more not to see it as a like sum up of rupiah only, but I try to see what are other elements that can be money, and I see that the underutilized asset is a value, as a very big value, and maybe it is the last resort that Jakarta has in terms of like scale that can actually mitigate this Jakarta sinking issue.
Yes,
I
yes,
hope
yes.
this
So there's
answer helps.
opportunity, yeah. Also, before we
Yeah.
move to the next questions, I also have question myself. I'm really interested in how you mentioned about the private sector and also maybe NGO, and we also have the stakeholder analysis. But in your opinion, for making this happen, which are the key stakeholders that really important? Maybe from the government, which government is the most important one, and yeah, for achieving this.
Okay, yeah. Thank you very much for the question, Mbak Sabrina. I see that this whole scenario actually quite simple because there's one main stakeholder that plays a pivoting role. It is the Ministry of Finance, because Ministry of Finance have all the powers that is required for this to happen. First, they have the land possessions. They have all the they are responsible for the asset management overall, and then they also have the state budgeting power. So we can actually like precedent that like the health costs that actually have to be like is an expenses on like BPJS, the national health insurance that maybe can be allocated for this can be rationalized to be calculated in this whole scenario as a uh, expenses cut. So I see this problem relate to the Pak Arif question also. Where's the money? And I see that okay, maybe it's not always about like the money, but it's also about the value that we can capture, the expenses that is can be mitigated. So all of this all of the prosperity that the Indonesia have, that like okay, Indonesia and Jakarta have, uh, there's a layer of Ministry of Finance role there, and it is actually a huge opportunity for Ministry of Finance because it also can address the issue of the underutilized asset that is not yet have any function after being left because of the capital city relocations.
Okay, thank you so much for the explanation. We also have other question. The second one is from Bu Cynthia. She asked about she compliments you the brilliant idea, and also can you explain more about the asset swapping, auction, and bidding, and what do the private sectors get in return?
Okay, yeah, thank you very much, Bu Cynthia, for the question. Yeah, for the asset swapping, maybe we can go back a little bit to the slides. Yeah. In this, okay, in this swap scenario, there's a state-owned asset, state-owned perspective, and then also there's a partner's perspective. As I mentioned before, a state has a lot of underutilized assets, and then partners can be from government, from the developers, from the maybe landowners have particular land in Jakarta that is not really lucrative or very hard to develop. They actually wanted it to be productive. And some of the reasons why it is very hard to be productive is because the location is not really strategic yet. So with this swap scenario, there's an opportunity for them to get a better located area, a better located property, and with this better located property, they can actually do business there. They can start to develop something, and in return, state have uh, their the partners' property, and this property that assumed to be located maybe in other part of central Jakarta, maybe like say in a northern part of Jakarta or southern part of Jakarta, still in the perimeter of Jakarta, but it is not as central as the state-owned assets. This area can be converted into green space, and because the state convert it into green space, then this green spaces actually can also be a very good catalyst for the new locations to have a better neighborhood. While in the partner perspective, they got a better assets in the more central locations. So maybe they can reuse, let's say, maybe there's a, we have to check this, but let's say the office of Kementerian Pariwisata can be repurposed for like a meeting hall or maybe a wedding hall. I don't know, like something interesting, and it can be leveraged by the private for business. Yeah, something like that.
Okay, thank you. So I hope that answers the questions of Bu Cynthia. So because we still have some time, maybe if Bu Cynthia have other follow-up questions, she's very welcome to write down the questions. Next one from Pak Paul. He asked that are there any mechanisms and are in place to ensure the compliance and also to prevent negative environmental impacts if we implement this kind of scheme?
Sorry, can you repeat the question?
Yes. So what mechanisms are in place to ensure compliance and also prevent some negative environmental impacts if there's any, maybe. But if you, maybe in your opinion, there will be no any more environmental impact by implementing this, maybe you can also elaborate that.
Okay, I can say thank you, Papal, for the question. I can say that this is not like a grand solution for mitigating all this environmental problem. This is actually just one one approach. Like I can see this as a quite significant, can have a significant impact, but it cannot answer all the problems because this environmental and urban challenges are a very complex problem, and it can be worse if we do not do anything to tackle this problem. And we can say that this is actually just a small steps of not as small, but I can say that we need the overall collaboration from every party, from every field to really think about the sustainability, uh, how to make Jakarta more resilient, because this is maybe just from the urban and real estate perspective. It is more to the asset management approach. There are a lot of things that we need to be executed for having a more effective, uh, to get into the Jakarta resiliency of Jakarta. So say that from this asset management perspective, we have tried our best, like to manage all the things to be more effective, but it is still need the support from, say, from the transportations department, from the government, local government, to implement policy that is more environmentally friendly. There's also there's private parties that also very much having a very great role in make things happen. They have to make a more environmental friendly decision. So this is the idea that I proposed just now is very much to the asset management thing, and I think that this is actually possible, but it is not yet executed, or maybe it is not yet there in our mind. So I wanted to like lower the barrier of this idea to happen, because we might not think in this kind of perspective. So I just hope that this is actually can be some inspirations for us. For I hope that maybe some consideration of the Minister of Finance hearing this, that actually the asset that they have can cut the expenses a lot. And this is not only like for the government or for the Jakarta residents. This is also very beneficial for the private party, because it can be a good business for them. And I think back to the four quadrant of stakeholder, we have to involve all of the stakeholder to actually get the benefit from it, so that the force towards the resiliency, towards the sustainability can be achieved faster and stronger. Thank you.
Thank you, Mbak. Maybe I have some follow-up questions, because that's really interesting. That from your opinion, what may be the biggest challenges? Like one biggest, maybe is it getting the stakeholders on board, or maybe educating the people, or what?
I can say that actually the biggest stakeholder can be how this actually can be aligned with the government agenda. Yeah.
Yeah.
Because we know that Minister of Finance already have like a very detailed guidelines on how these assets actually have to be refunction. I know that there's a big limit, like a very specific limitations for an asset of a state-owned asset to be converted or to be sold. It and as far as I understand, it even cannot be sold. It even cannot be like demolished. So there's, because it is like the property of the state, so it is very valuable. So there's a lot of existing guidelines that needs to be followed, that needs to be addressed, and all of this idea is happening because of the high level informations. I don't even know that all of the assets of state on the Minister of Finance. I don't even know, but I just know the numbers of it. But
Yes.
all of these things actually, if we're only like following the guidelines, or always following the guidelines, and did not like rethinking about what actually can we make better, I think that's why in the first of the presentation I said that this is a quite disruptive idea, because I'm aware that there are a lot of guidelines that needs to be followed, but maybe if if there's a collaboration from several ministry, from the I can also say like the Jakarta government, the Ministry of Finance, and the Kementerian Koordinasi.
Yeah.
It maybe makes sense for everyone to execute this because at the end of the day, Jakarta, if it is no longer becoming a capital city, still is a daerah khusus, ibu kota, right? It
Yeah.
used to be daerah khusus, so it has to get a special attention. It has to treat it differently. So I don't think that it is not executable, but I must admit that it is hard and needs a lot of coordination. Yeah, thank you, Mbak Sabrina.
Yes. Thank you. Last question before we move on to your closing statement. Are there any best practices from other countries that have implemented this?
Okay, yeah, thank you very much. For the asset swap, it is I do there's a quite practice like this. It is in Japan, every developers that want to develop something in the city, they have to allocate certain amount of green space in the outer part of the city. But for like the exact same practices, it is not really there yet as far as I understand. But uh, there's a Bangkok. Bangkok in Thailand has this kind of approach to add the green space. They open up like a very huge park. It is called Centennial Park. It is used to be like the land of a university, but it is converted into like a very huge urban park that that can be leveraged as a uh, for as a urban public space, so that there can be a gathering, there can be events there, but there's also a lot of good vegetations for absorbing the CO2 and then also for absorbing rainwater. And then they have a very big tank for mitigating an immediate flooding. So it actually can mitigate the flood immediately because there's a big tank underground. It can help with flooding that is coming from Bogor area, but
Yeah.
it actually also can help the organic rainwater absorption. So it is actually there and we can see it as a benchmark for the projects, and we can replicate it into a larger scale.
Okay. Thank you, Mbak. And last one, maybe just short one. Can you give closing statement for the presentation?
Okay. The closing statement will be referring back to the Ilan Kelman book. The disaster is not something coming directly from the nature. It is actually can be involved. It is actually involving our decisions as human to make a good governance out of it, out of the natural phenomena. And the most important thing is it is we cannot see the natural phenomena as a threat, but it is actually an opportunity for us to capitalize it into some opportunities to actually creating a good business out of it. And it is very lucrative after all for several parties, for all the urban stakeholders. So the thing is, maybe we have to see it in a different perspective. Didn't see money as a hindrance, but maybe the money can come from the cut off expenses. Yeah.
Yes, thank you so much, Mbak Priscilia, for the presentations and also the question and answer. Sorry, I read your institution wrong. You are from University College of London, right? Yes, I apologize for the
Yeah,
mistake.
it's okay. No
Yeah.
worries. Yeah.
And for the attendance, don't forget to fill the attendance form. It will be different for each session. So don't make sure that you still the right one. And also there is an ongoing polls for you can vote your favorite presenter. You can vote for most engaging, impactful, visible, collaborative, visionary, and also centric. I think that's all for the Mbak Priscilia sessions. Thank you all. So let's wait for the next presenter. Thank you, Mbak.
Thank you very much, Mbak Sabrina.
again, everyone. Good afternoon. I hope you are still energized for another 2 sessions in Indonesia Sustainability Forum Virtual Academic Dialogue. So we have our next presenter. We have this is also my very good friend, Ria. She's currently studying in MIT, and she will present her research regarding which titled "Enhancing Coastal Resilience: Applying Decision Support Framework for Nature-Based Solutions." Do we already have Ria here?
Hi, Kak
Hi,
Sasa. Nice to
how are
meet
you, Ria?
Yeah, fine. How about you?
Okay,
Nice
I
to
think
meet
we
you.
all wear red because Mbak Priscilia also wear red. Are you ready for your presentation?
Yeah, and actually, today I will present the research
Yes.
together with my colleague, Valen
Okay.
Ranggagirina, but maybe
Ah,
like we will split our part, and
okay.
he's actually also ready to present. So yeah.
Okay. So, will he also join the Q&A session?
Yeah. He's
Okay,
also
yeah.
joining the session.
Okay, so you guys will have 30 minutes for the presentation and then followed by 20 minutes of question and answer. So I think Ria and her friend, the time and floor is yours.
Okay, thanks. Okay, good afternoon, everyone. Thank you for the time, and maybe like let me introduce myself. My name is Ria, and here actually, this is the research project that I was doing together with my colleagues in Royal Haskoning DHV. So the title is about the enhancing coastal resilience, applying decision support framework for nature-based solution. But before we start, we would like to say thank you to the International Sustainability Forum Committee, as well as our moderator, Kak Sabrina, for the opportunity for us to present and show one of our project. And actually, this is the people behind the decision support framework. So here we have Valen Ranggagirina as integrated coastal climate adaptation specialist, and also Nafisa Nurbandika as environmental and social safeguard, as well as biomanagement specialist, and myself, Ria Ferencia, as a water resource engineer from Royal Haskoning DHV. But currently, I'm also doing my master's in climate, environmental, and sustainability in Massachusetts Institute of Technology. And actually, to start everything, we were taking a case example in Sayung Demak, as we can see that this is time lapse from Google Earth from 1986 to 2021. And as we can see that in 1986, like the part of coastal area in Sayung Demak we're actually like a coastal land. While in 2021, everything's changes. And actually, some parts of the area were swallowed or flooded by the seawater. So we can see that the significant difference in the coastal area. So this becomes the background that everyone knows that the climate change rapidly happens recently. And actually, there are a lot of impacts, and the impacts that we consider in the coastal area are actually the heavy precipitation, tidal level increases, and also sea level rises. And maybe these components or factors makes the coastal area, some part of coastal area in Denmark, as we take as one of the case example, happened. And as we are also know that the coastal development are happening due to the rapid population growth. And based on the recent research also like in the world, like more than 50% population that living in the coastal area. And as we can see, taking Indonesia as one of the case example, we know that we have the long shoreline. So that's why we really consider the coastal area to be more resilient. and because of the impact of the climate change. And it leads into the two main problems. The first one is the increase of the frequency and intensity of hazards, and the other one is about the exposure and vulnerability of the coastal communities. And next to the more complicated factors, as we know that the climate change happened, and if we look deeper into the Indonesia cases, there are a lot of factors such as the weak governance, poverty, ecosystems that collapse maybe year by year, and within the uncontrolled urbanization and biodiversity loss, and it just worsens the conditions and also the impact that climate change brings. Well, we can see if people can build a concrete seawall to like protect the coastal area from flooding, but actually it can just worsen the condition. So, and most recently, we are trying to have the transition from gray to green infrastructures, or even like the natural barriers. So we have like more adapted area and have more adaptation to the climate change, especially for the coastal communities. And as we know, the transitions and from gray to green infrastructure and the hybrid between those two are called the nature-based solutions. And the points is the nature-based solutions brings the opportunities like start from the environmental, social, and also economic. As we can see, like for the environmental, we have like different type of coastal ecosystem, like mangrove, sandy, or muddy coastal ecosystem, and these nature-based solutions measures can adapt well within the different case of environmental, as well as like the NBS or nature-based brings the social benefits like addressing the inequality and unemployment, and also brings the adaptation or mitigation of the disaster risk and land degradation, and the last one about brings the economic impact to the coastal community. But actually, there are some challenges that we consider, which are like the lack of initiative framework for the mainstreaming NBS itself, especially in Indonesia and Southeast Asia, a limited concrete planning and recommendation, and the absence or the lack of guidance of how to implement the NBS, how to assess and align the NBS to the coastal communities. Therefore, we just propose a decision support framework or DSF for implementing NBS, especially in coastal area of Indonesia. And actually, this is the list of potential NBS, and maybe
thank you, Ria.
Yeah.
Yeah, so basically what we were doing previously before we start preparing the DSF, first we make like a long-term list of the potential NBS. So we look at a lot of reference and also a lot of like a project reference in worldwide. So basically this is the 14 potential NBS that we thought that this NBS can be quite applicable in Indonesia, especially. And then based on this following NBS, we also found out that there are quite some NBS that has a variance. For example, when we look at the artificial reef, we also look whether the artificial reef can be as a gabion with the gabions, or also related to the restoration of the existing reef, or even when we look at more simple like a biorock or something that are also part of the variant for the artificial reef. And also when we look at the coastal protection function, we actually look at least there are three functions. The first one, NBS that have a function as a flood protection, and then also NBS that have protection as a wave attenuation and also for erosion protection. But we also look at the NBS that are actually they are as an add-on. So basically they will only provide function as biodiversity enhancement. And also when we look at the NBS, but I will expand it later, we also look at quite a lot of criteria when to be considered when we are preparing the DSF. Next. Okay, this is the criteria the criteria that we consider in our DSF. The first one, we look about the maturity. So in terms of the maturity, we look at whether the NBS are now in early stages or already implemented somewhere worldwide, or even already implemented in Indonesia, but need more upscaling or mainstreaming. But when we look at the environmental suitability, we also look at the condition of the coastal morphology, whether it's like a sandy beach or estuary or even like a urban coastal area. We also look at the slope, at the ecosystem type, whether it's mangrove or whether it's like a area with quite a lot of coral. And also we look at the multifunctional benefit, whether they provide also for water quality improvement, carbon sequestration, fisheries, recreation, and tourism. And also when we look at the implementation parameter, we look also like a design and construction complexity, which are divided into high, moderate, low, and also adaptability level, how they can adapt with the increasing sea level rise, with the increasing temperature due to climate change. And also we look at the operational and maintenance, and also we look at the cost in terms of United States dollar. Next. And also when we prepare the DSF, so we are not only looking DSF as a tool, but we also consider how the DSF can be like a user-friendly. And also we look at user interface and also user experience, UI and UX. The first one, we put quite some requirement. The first one is that the DSF should provide like a clear guidance what the user should do in terms of how they can use the DSF. And also the DSF also give like an overview of the available NBS in terms of the, we call it like the attribute of the criteria that I have explained previously, and also explanation why certain NBS may be not feasible in a certain location. And also we made the DSF to be able to generate like a report mentioning, okay, what are the NBS that are applicable, that are feasible, and also along with their photos to give user more information about that. And then also DSF should be able to provide like an instant result. So in a case that the user change their criteria or change their preference, so it doesn't take quite a lot of time for the DSF to show the result based on the user preference. Next. And basically this is the flow chart. So when we look at the DSF, so the flow chart or how the DSF work actually quite simple. So basically we have this, like I mentioned before, we have the attribute, and then we put, so for each of the NBS, they already assigned with a certain attribute. So for example, like a mangrove, they have this criteria 1, 2, 3, and 4. And then like when the user put their input there, so there will be like a matchmaking process. So it means that in the matchmaking process, the DSF will look if certain NBS actually meet all the user input on the criteria. If yes, so it means that this NBS would be potential, but if not, it would be still mentioned, but there will be like a boundary line between the suitable NBS and less suitable one. And then this is like and then when we prepare the user input, so user input will be submitted as questionnaire. So we have quite some questionnaire. So either the questionnaire as a drop down, so you can select multiple criteria based on the question, or it's actually based on the card type question. So you can only select one of your preference. Next. So this is the result. So, but Ria will explain later and give you a demo on how to use the DSF. So basically, in terms of the result, you will find like there are like two panels. The left panel, it will show the list of the criteria as submitted by the user. And this in the left panel, you can also change it in a case you want to adjust your criteria. And then like in the right panel, so you can see that there are quite some lists of the suitable NBS which are shown in the green boxes, in the green box, and then also the list of unsuitable NBS shown in the orange one or the yellow one. When you click, for example, when you click the suitable NBS, it will show you the name of the NBS, the example where it's already implemented, and also some description about the NBS, and also the attribute comparison, how they are complying with the user criteria. And also in terms of the panel, they will show more information about the list of the attribute, and then hopefully we'll help the user to determine whether it's still suitable for them or not. Next. Yeah, Ria will explain about how we can use the DSF for our cases in the map. Thank you, Ria.
Okay, thank you, Ms. Valen. Okay, let me continue. So for the case example, as we will show you some demo of this decision support framework, so we just take the case example in Sayong Demak as we have shown you at the beginning. So actually the case is about the coastal erosion that harms the communities in northern Java, so affecting and hundreds of kilometers of coastline and more than 3 kilometers of land, including the entire villages, have already been flooded by the seawater in Demak. And actually, we did some research, and actually the land is characterized by the muddy coastal conditions and the critical nursery role of mangroves for some fish species also has been lost. So here is the demo of our tool. So the first one, as Ms. Valen has explained before, we just fill it some questionnaires. So it is like for sure, and then we select the function, what function we would like for our NBS implementation, both primary and secondary functions, and about the maturity, which level of the maturity, and we select the implementation. And it is about the environmental suitability. So the coastal is muddy coast, and it is about the planning parameters. Actually, it could be adjusted based on what user or engineer needs and also like meet in the field. So first about the construction complexity, we chose the moderate. Adaptability, we chose high, and complexity low. And while this is the result, as we can see that there are two suitable options for NBS. The first one is about the mangrove restoration planning, and the second one about the constructed for shore. And we can see like the card type, there are several definitions, not only the suitable, but also the unsuitable one with the more muted colors. So yeah, that's the demo. And there are several checklists that of the enabling NBS that the users and also us as an engineer must aware. So actually that the users should analyze by themselves the proposed location in addition to DSF results to address the local issues, including the permits, the compliance, and also the financial affordabilities. Why these three things must be considered. So for assessing the permits, it is clear that for constructing the NBS measures in the project locations, we must consider the permits in the specific locations. And we believe that each coastal area like has different permits applied. And The second one about the government regulations, especially on the environmental protection and also management. So we and also the users must comply with such of regulations. And the last about the financial sustainability and also affordability to implement and to construct the NBS itself. So after we know that we have certain financial affordability, we can make sure that NBS measures not only like could solve the problem, but have the sustainability in the long future. And actually, this is the last one about the future works. So we still have some things to do in the future. So the first one, it includes the additional filtering attributes and also considerations that would be incorporated, including the environmental suitability criteria. As we know that for this pilot projects, we have not included several factors, and maybe in the future, we hope that we can include the factors such as the currents, the sea currents, and then cyclones and sea level rise, wave height, and also the social conditions maybe could be considered. And the second one is about that we know that this pilot project of DSF is only about the filtering. So maybe in the future, we could add the scoring and weighting system to further enhance the accuracy and also efficiency of the DSF itself. So it could generate better results to the users as needed. And the last one, as we know that this DSF is in the corporate stage, so we can move from the corporate stage to be released to public and made as accessible online. So this tool can be used worldwide, especially in the coastal cities. So I believe that's the end of our presentation, but we are very happy to have some sort of questions and answer after this. Thank you very much.
Okay, thank you, Ria and Mas Valen, for a very concise presentations. Maybe I will highlight some points that Ria started by mentioning about the coastal problem with the Denmark study case, and also continued by also nature-based solution as one of the solutions. And then Mas Valen continued by mentioning the options of NBS, especially for in case of coastal protections, and also the evaluation criteria. And Mas Valen also explained very clearly about the process for each step in applying the framework. And maybe while we are waiting the questions from the audiences, I myself also have some questions. Maybe the first one is why did you use the Denmark case for the study case? Is it because the extent of the problem, or maybe because of the data availability, or what reasons?
Okay, maybe I can answer first. Yeah, thank you, Kak Sabrina, for the questions. And actually, like Denmark cases are such unique because there are already some implementations of the nature-based solution from the several consortium, and also like such as the Invest International has invested some NBS measures for the permeable structure. So there are several research already deployed in that area and pilot projects the NBS itself. So we hope that by taking that Denmark cases, we can have sort of comparison with the real deployment of the NBS itself, and also like see the validation of the tools that we are developing right now, whether it has like some comparisons and also like suitability with the real cases happened. And not only because of there are already several NBS deployed there, but also like the cases are unique because we know that several things happens, including the coastal erosion, and also like maybe we can see the type of the coast area which is the Marico. So like we have sort of information to put as an input for our DSF. So maybe that's why we take the Denmark cases as the one of the example.
Okay, yes, thank you. It's very clear. Also for the audiences, if you have any questions, you can also write down in the Zoom or in the YouTube. Maybe the next questions. I'm also curious about in this kind of solution, sometimes we have to gather like social data, for example, interacting with local people and yeah, that kind of social data. And maybe the suitable solution from their point of view. Are these process included in the framework and how does it include?
Yeah, I think I can help answer that. So as for now, because it's still a prototype, so we only look at the technical. Basically, most of them are technical requirements, because you know that for especially for the socio-economics, especially for the social one, it's a bit difficult to somewhat quantify that. I mean, like we can
Yes.
also include them as part of like a qualitative measure, for example, like. Because when we look at the social condition, we can also link how the NBS can give like a multifunctional benefit. For example, when we look at mangrove, for example, because for mangrove, for example, mangrove does not only provide the protection to the coastal, but at certain point, maybe mangrove also give more in terms of like fisheries. For example, it can be like a breeding area for fish, and then at certain point it can also increase the catchment of the fishing community, something like that. It means how we can link this to the social condition, how it can improve the social condition. I think we need to have more research on that. But in terms of the current research worldwide, there are quite some study already done worldwide. But again, like Ria already mentioned, like social and economic are quite specific to the area. So of course, even though we have like a reference from another international study, but sometimes the social condition might not be the same. So that's why, as for now, we have to admit that it's not yet included, but we are planning to include them as an update for our DSF.
Okay. I also have some follow-up questions. So, if you mentioned that there are some international research, are there many research in Indonesia context for maybe the benefit in social and economic that maybe can be incorporated in the framework in the future?
Yeah, because when we look at the current knowledge also, NBS, I don't think like the current knowledge of the NBS are not quite well known in Indonesia. So even when we talk about the NBS or building with nature, not everyone really knows about that, right? But I mean, like when we look at like a green infrastructure or green solution, maybe people are quite known about this one. So that's why the first thing before we look further on what are the research that are currently ongoing in Indonesia, first we need to encourage people or to give more information about what are the NBS, because I think once more people know about the NBS, I would think that there will be quite a lot of research for this kind of topic.
Okay, yes. We also let me check the question from the audiences. Okay, I think people are still typing. I want to follow up again. I think this is very interesting topics because like as Ria mentioned that social economic impact is more of case by case, maybe per countries will be different case. So is it correct if I say that maybe Indonesia has to build also the standard for that we as a country or maybe per region will be different? What do you think?
Okay, thank you, Kak Sabrina, for the questions. Yeah, I think like to have sort of socio-economic context, usually like it depends on each region. So for example, if we deploy a project in some area, there would be like the social, what we could say it like the social visit, and then like some of social or stakeholder management and engagement. So that's why I like to build some of framework, especially on the social and also economic. It is really needed case by case, and actually it is good to have the framework for all areas, but still we actually need some of the stakeholder engagement in each area, which we believe that each area has like different approach in terms of the socio-economic. So yeah, for example, taking some example in coastal area in Sumatra, and also like compare it to coastal area in Java. So we believe that the approach and also like how the socio-economic just built and also develop that area are sort of different. So like the framework to address the socio-economic issue is actually good to have, but still we believe that when we would like to deploy some project, that we must consider the socio-economic landscape that might be different for each area.
Yeah, and also to add Ria, because as for now, like I mentioned, not people knows about NBS, right? So the thing we can do, we can also prepare the so-called community perception survey. So I think it would be good as a start for our project. So at least we want to know what are the community will think about the NBS itself, because as we know that NBS is not only is a community work, right? It's not about okay, government just or anyone build the NBS and that's all. But of course, the NBS need like sustainability. So that's why we need as much as possible involvement from the community. So that's why I think this community perception survey will be like a very important, where we can invite like the community leader, NGOs and something to learn together with them, to encourage them on how we can make this NBS as a long-term investment for our coastal protection.
Yes. Okay, Ria and Mas Faren, thank you for the answers. We have questions from audiences. We have question from Pak Paul. He asked that how will the framework be disseminated and made accessible to different stakeholders such as communities, government officials, NGOs, and researchers?
Yeah, I think as for now, because the NBS, the current DSF are now still like a web base, so it's now still within our company server somewhat. So I think it would be interesting in a case that we can find like any institution or something that can help us to also like publish this DSF, because of course when we want, because the idea or the objective, we want to have this DSF always updated, right? Always maintenance and something. It means we need someone that, or any organization or any partner or any college that can help us to also maintain this NBS, because once when we look at the DSF also, we need to also update with the, because as for now we only have like less than 20 lists of the potential NBS, but I believe in the far future we may have more and more solution from the NBS, not only related to the coastal protection, but can be also related to the like urban NBS, like and also can be linked to like a green building or something. So while we are now preparing and updating the system, so I don't think that as for now it's already quite mature to be shared to the public, but later once we update it with more features, I mean like we can also put like a scoring or weighing or something, so that people can have more benefit to this tool. I think at that point we can find we were trying to find like a partner to help us to also develop and maintain this DSF.
Okay, yes, well noted, Mas Valen. It's also related to maybe next questions. Someone asked that what kind of study case that is suitable for the framework. So maybe based on your explanation, currently it's still coastal, or maybe can it already be used in a catchment, for example, in general?
Yeah, to be honest, it's not yet at that point. So as for now, we're only looking at the coastal protection functions. But of course, like in terms of the list, we already gather quite a lot of lists. For example, like freshwater wetland, or we can also look at like I mentioned, like a green roof, or even like a spawns, like a floating wetland and something like that, that can be actually applied not in the coastal but also in the inland or urban area. But I think when we look at the function itself, of course they will provide like a different function, right? So that's why we can also update it in our next part, that it can also cover the other NBS that are applicable, not only coastal but also inland, like a catchment, like you mentioned. That can be always possible. Yeah.
Okay,
I
yes.
also
Thank you,
would
Mas
like
Valen.
to
Yeah, I
add
think Ria would
some.
like to add something.
Yeah,
Yes, sure.
thank you. So actually, yeah, just want to add that previous question about how to disseminate the tools to the larger communities. Yes, as Mas Valen has mentioned before, it is like corporate based, and we have also explained that our future work is that to move from the corporate base, so it could be accessible online. And actually, like the filtering tools like this, especially for the NBS, has already been there in the the general use. For example, if we know that several filtering tools from the echo shapes to filtering some sort of NBS, and it actually could be used for the larger communities. But what we would like to emphasize here is we still need to develop some sort of criteria to be input, and also like the scoring and rating system, so that the measures could be more, the DSF could generate better results of the NBS options. And especially for the application of the framework itself, maybe in the future we would just divide the location into the catchment base. So it could be like the urban and also the coastal, or the river stream, as it has already been developed also in the World Bank catalog for the NBS. And it is like the catchment base, and also like differentiate between the upstream, midstream, and also downstream, including the coastal area. So actually the framework in general has already been there, but our approach is like more the location context, and especially in Indonesia, how we could like adopt that big and also general framework into the more localized, so that everyone in certain places, in particular and specific places, and for right now, for example, in coastal area, could use that framework to support the selection of the NBS measure itself.
Okay, thank you. Very well explained, Mas Valen and Ria. Next question. Can you elaborate more on the financing mechanism for NBS projects? Are there plans for integrating financial sustainability considerations into the framework?
Yeah. When we look at the financial feasibility, especially, we know that most of the cases we look at that NBS actually, when we look at the coastal protection, at some cases they do not provide like a direct benefit to the coastal protection. So we could mention for some NBS, they are only like a supporting on the coastal protection measure. So it means we need to have like the hybrid solution instead of to have NBS as a standalone, right? So it means that in terms of the finding of the financing of the NBS, so of course we can compile them or combine them as a couple with more gray NBS. For example, like if you have like a project, especially from, for example, from the Ministry of Public Works and Housing, if they have like a project for a dike or a seawall or anything, I mean, like it would be good at certain point you also include this NBS, like as simple as mangrove, to be part of your coastal protection. So it means that NBS will not be considered as a separate solution, but it should be considered as a combined one. So at certain, for example, when you combine them, if you have like a dike or seawall with mangrove in front of it, so it means you can make your dike or wall or something, you can make it lower, because at certain point the wave that are coming to this dike or wall will be also reduced, right? So you don't need because you can have your dike lower, it means you can also reduce the cost to build this dike. It means that this reduction of the cost can be used to build NBS as like additional feature within this coastal protection function. So it means that we can also ensure that NBS still have a portion in terms of the planning for the coastal protection, rather than we would like to find like a separate financing for this NBS as a standalone.
Yeah. Yes. Okay. Yeah. Maybe Ria want to add?
Yeah, actually, also this is like interesting, and I think it is like a growing issue about financing the, let's say, green infrastructure. So I believe that, yeah, right now, like sustainable financing and green financing is growing, and actually one of the considerations of, or one of the goals of finance the measures is finance the NBS itself, which for example, the objective or the result of the measures to protect the coastal area, for instance, like cannot be seen directly, but it is more like the long-term investment and like the indirect benefit to the communities, such as we can see, like the NBS provides several opportunities, such as the economy, social, and environment. But actually, in the 1, 2, or like short-term period, by invest in the NBS measure, we cannot like directly see the benefits of the social environmental, but we can make the time faster. Like we can see the long-term result of the NBS itself. We believe, and most ongoing research believes, that NBS could provide such socio-economic benefits, especially to the environment and community. So like we believe that, right now we must work together on solve the climate problems, and one of the solution is about the sustainable financing. And actually these discussions are still going until now, and based on like the last 10 World Water Forum, also there's the specific thematic group which discuss this sort of sustainable financing topic. So yeah, that could be also one of our considerations why we believe that NBS could be one measures, and why we need DSF to implement that measure, so that we can have like the better planning, and also like can choose the suitable NBS in certain on specific location.
Okay, thank you so much, Mas Valen and Ria. I think I want to highlight 2 important points from the last discussions. That the first one, Mas Valen mentioned, it's very important to have mindset that maybe in some cases NBS is not a standalone solutions, but rather it has to be integrated with other infrastructure, for example. And also, Ria mentioned that it's also challenge from for NBS context that the benefits don't come directly, but it's very rather a long-term benefits. So I think because the time is up, I think I will have some closing statement from you both. Maybe start with Mas Valen and then continue with Ria.
Yeah. Okay. Thank you very much for inviting us. Just to note that, of course, for the NBS, actually there are quite of potential to be implemented in Indonesia, especially. So of course, like we mentioned previously, a lot of research would be required. So I think it would be good if for young people like us can already have interest on this NBS, because I would think that in the future, especially when we look at the climate change, when we look at the climate change become worse and worse, I think it would be good in our future that we can find this NBS as part of the solution, not only for the coastal protection, not only for like the flood protection measure or something, but also as our effort to survive on this climate change and also to build like a better condition for our future.
Thank you, and
Thanks,
Ria.
Mas Valen. So yeah, I just add a little bit about the closing statement. So I have 2 points. The first one about collaboration. We believe that when we would like to develop something, the collaboration, especially from the different discipline and background, is such important. So like taking this small research project from our company, that we consist of like different background, like the one is integrated coastal management, the one in biomanagement, and also social safeguards, and me myself as the water resource engineer. So take this example as like, yeah, this small start as an example how collaboration is actually really needed in the real world, and how we can like implement such projects. And in the larger scale, we believe that collaboration among stakeholders really matters, including like the community participations. And the second one is about the research. So I just believe that and realized through this virtual academic dialogue, such research on the ongoing project, or not only project, but actually the small things happen in this community is really matter by having the research on that. So by having such collaboration, also deep research on specific topic, we believe that we can address the certain issues in our uncertain future. So yeah, and also thank you very much for the opportunity, and we believe that we can always collaborate together in the near future.
Yes, thank you so much, Ria and Mas Valen, for the engaging discussions and also the time for the presentations. I hope that the discussion about NBS can always grow in the future. Thank you for your time. And for the
Thank you.
attendance, don't forget to fill the form. Yes, thank you so much. And we also have ongoing vote that you can also vote for the most engaging, impactful, visible, collaborative, visionary, or community-centric presentations. Okay, so thank you, Mas Ria and Mas Valen. So now we are waiting for the last presenter for today. Hello again, everyone. Now we are in the last presentation of Indonesia Sustainability Forum's virtual academic dialogue. We have one last presenter. We have Mas Munawir Bintang Pratama from University of Edinburgh, and will present his research titled Tidal Current Energy in Indonesian Waters, List of Potential Sites, Sunda Strait Case Study, and a synthesize for general characterizations. So, Mas Munawir, are you already there? Yes.
Yes, can you hear me well, Sarah?
Yes, perfectly. How are you, Mas?
Yes, very good. Thank you very much. How are you?
Yes, I'm good. Are you ready for the presentation?
Yeah.
Okay, so you will close this session. So you have 30 minutes maximum for the presentations and then followed by 20 minutes of question and answer. So, Mas Munawir, the time is yours.
Okay. So I would like to check first if the slides is already fileable.
I think we're still waiting.
I have shared screen and
Okay. Wait. I think we're still waiting for the share screen, but in the meantime, you can start by introducing yourself.
Yep.
Yeah, it's
Okay.
visible now. Yes.
1 second. I'll just have a look on what's on my screen. Okay. So good evening, everyone, or I should say good morning, good afternoon, anywhere. So my name is Munawir. I'm a PhD student at the Edinburgh University in UK, Scotland. And this is my MSc research back in 2019-2020. The topic is about tidal current energy in Indonesian waters. So I will talk about the potential sites, a case study at Sunda Strait, and general characterization, which is developed from intercomparison of multiple sites. And I also would like to acknowledge the support from my supervisor, Professor Venugopal, and of course, immense gratitude to the organizer of this virtual academic dialogue. And I also would like to appreciate the other 26 wonderful presenters. So yeah, I'll just go right into the next slides. So there will be 5 parts in this presentation, from background to discussion and remarks. And I'll just go right into the first, which is part 1, the background. I can open this presentation by describing the nature of tidal current. And the best way to describe the nature of tidal current using my material is by a demonstration at Sunda Strait. So at the top here, this is the water level in hourly during a day. So as you can see, there are 2 high tide and 2 low tide within 1 day. And during this period, this is the flow field at the bottleneck of Sunda Strait. We can see at some time there is a very strong velocity going northeast, and it will weaken and shifting to velocity going to southwest. So this is the nature of tidal current, which is periodic or cyclic, and it is very predictable as the forces that induce this tidal current, which is the moon and the sun and other astronomical forces, is pretty much already known. And what is tidal current energy? So maybe the most comfortable way to introduce it is by showing this wind energy, which is implemented in Jene Ponto in Sulawesi Selatan, which is a turbine like a fan stand on the land at open space topography. However, for the tidal current energy, the energy is harvested from the tidal current. Therefore, you put analogically similar turbine into the seabed. However, you can see that the turbine is little bit smaller and the structure is more robust or larger. So it stands on the seabed, or it can be floating, or there are another technology. and located most of the time at a constricted channel. For comparing the flow speed and wind speed, the flow speed at seawater is relatively smaller, and the water density is about 800 times larger than the air density, and the diameter is about 20 times of the tidal turbine is 20 times smaller or 10 times smaller than the wind turbine. And this tidal current energy itself is the second generation. The first generation is tidal barrage, which you build a big dam at the coastal area with very high tide, and you can regulate the opening and the closing of a valve, which will turn a turbine and generate energy. And then from this, I can say the advantage of tidal current energy. Number one is less environmental impact compared to the tidal barrage, because you don't block or doing massive modification to the water bodies. You only put one fan-like structures in the seabed or floating in the cross-section of a strait. And as I mentioned, the nature of tidal current, it's predictable and less impacted by the weather. And also it has more concentrated energy density due to the nature of the fluid, which is seawater, very high density. And this is a little bit outlook on the development of renewables in energy transition in Indonesia based on the presidential decree in 2017. The main takeouts from this, which is at the top, the most right part, which is the others, where the value is about 6,100 megawatts installed capacity targeted in 2050, and tidal current will contributing at this as one of them. And then for now, at least there are 7 technology for harvesting tidal current of energy from tidal current. So the most traditional one using a seabed mounted turbines, or you can have floating turbines, and there are other more technology. They are different based on their supporting structures and rotating axis, and each device has different mechanical and electrical specification, like the rotor size, efficiency, power curve, and edge. And to develop this kind of turbines, you have to know your site characteristics. So you can suit your turbine to the characteristic of the tidal sites at your location. And this is 3 installed tidal current devices, and there are more. I only present 3 of them. Orbital O2 at Scotland, Sabel at France, Minesto at Faroe Island. And the installed capacity is about 1 megawatt or 2 megawatt. While the capacity is still lower, the levelized cost of energy is relatively higher, about 300 or 280, which is massively larger than other source of energy. However, with the techno analysis by Tiger 2022, can be expected the price might be lower into similar or a little bit higher price in 2035, and it will be declining as the time, similar trajectory as the wind energy. So there is a potential of using tidal current energy by the time and also by increasing the capacity. This slide is too much information, but the highlights would be on the lower side, which is the expenditure breakdown in real tidal farm in percentages. So when comparing the development, capital, operational, and decommissioning expenditures, the most dominating cost would be from the capital expenditure and operational expenditure. And from the operational expenditure, mostly is like general or fixed operational, like maintenance, service, onshore infrastructures. And for the capital expenditures, it will be about mostly contributed by the turbine cost. However, if you have demo projects, the capital expenditure will be dominated by the infrastructures. So to have these tidal current energy devices working in our tidal energy sites or our waters, we need to have lower capex, lower opex, therefore lower levelized cost of energy. And to achieve this, it is important to enhance or improve the turbine, the infrastructures, and the farm operations. And to support this, I took an approach using the ocean hydrodynamics model, from where I will do resource assessment, site characterization, and tidal farm design. And after doing this, it can be feedback again to this turbine, infrastructure, and operations, and going back into the CapEx and OpEx, going lower. So that's the opening. I will just go right into the second part, which is about the potential sites. This is the list of potential sites I have compiled in MSc dissertation, collected from 38 research articles with key references from Asosiasi Energi Laut Indonesia and web portal from Kementerian ESDM. So at least there are 20 tidal energy sites. However, I suspect there will be more than these 20. And most of them concentrated between Sumatra to Nusa Tenggara Timur, across the tiny straits connecting islands at the southern part of Indonesia. So this is the summary of the 20 sites from the most western part, Riau Strait, to the eastern part, Digul River in Papua. And this is the amount of study have been conducted, and only small amount of them that including the tidal turbines in the simulation. And this is the distribution of maximum flow speed. It can be seen the weaker flow speed is about 1 to 1.5 meter per second, and the higher velocity is about 3 to 3.5 meter per second. So to put it into matrix, this is a matrix still under development on the Indonesian tidal energy side. So we can have a location with higher potential, with larger population around the location, like Bali Strait, or there are locations with high potential, high velocity, but smaller population, which is at Chapalulu Strait at the North Maluku province, and lower potential and smaller population around this area. Or it can be summarized with this inside the purple box, which is a tidal current energy as a general alternative, or we can use tidal current energy as a diesel replacement for a remote area or smaller population. Now I would like to go into part number 3, which is Sunda Strait case. This is a modeling exercise with 6 objectives, from constructing numerical model to investigate the tidal farm interactions. So in this research, I did data collection and then doing model construction using Delft 3D. And then from the model result, I characterized the tidal hydrodynamics at the area of interest, which is Sunda Strait. And then I advanced the model by incorporating tidal turbines in the model. And then from the model result, I investigate how the tidal farms influence each other's. So this is the site description of Sunda Strait. It's located between Sumatra Island and Java Island. This is a closer look showing the bottleneck of Sunda Strait with width about 50 kilometer wide. And there are islands within the bottleneck of the strait, Sangiang Island, Panjurit Island, and other islands, which make the geometry of the strait is pretty much complex. And this is a little bit about the model description. I use Delft 3D Flow. There is 5 domains to make the model efficient and computationally affordable. So at the boundary, I can have mesh resolution about 1 kilometer, and at the area of interest, 20 meters. And at the area of interest, I use 12 sigma layers in the model. And the model is forced with tidal harmonics from the TPXO. And I did model validation to ensure the reliability of the model. From here, it can be seen the model compared against the current velocity measured at Anyer show a satisfactory result, and the water level validation from the model compared against 4 stations also showing a satisfactory result. And then this is the description of the flow field at Sunda Strait. this is the same slide I used to describe the nature of tidal energy. The highlight from this is like there is a cycle between high velocity to northeast and high velocity to southeast. I think it better explained in this animation. Hopefully it's work. Yeah, it's work. So this is hourly flow field resulted from my simulation at Sunda Strait. The main takeout from this simulation is the velocity, the area with the highest velocity is concentrated between these two islands at the bottleneck of the strait, which is Sangiang Island at the southeast and the northeast area, Panjurit Island. This is again to highlight the area with the highest velocity, which is at the north of Sangiang Islands and the southeast of Panjurit Island. So from this area, it is suspected that it is suitable to be the site for developed tidal farms. And to confirm this hypothesis, I calculate the mean speed over 1 month and also maximum speed over 1 month, and the flow speed percentage of flow speed larger than 0.5 meter per second over 1 month, and the mean power density over 1 month. And they are all indicated that the most suitable location for harvesting tidal energy at those locations at Panjurit waters and Sangiang waters, where the mean flow speed around 0.7 meter per second, maximum flow speed is over 2 meter per second. And then from this, I developed a hypothetical tidal turbine farms. So from Panjurit waters, I built 2 tidal farms, Panjurit 1 and Panjurit 2, each with 24 turbines and 12 turbines respectively. And at Sangiang waters, only 1 tidal farm with 24 tidal turbines. And also in this study, I currently use a hypothetical tidal turbine, which is adapted from various combining parameters from various existing tidal turbines, which is 1 megawatt capacity, 20 meters diameters, and certain spacing to facilitate less disturbance between tidal turbines. And the tidal turbines incorporated in the model and mimic using the porous plate features in Delft 3D and also replicated in the 3D plane. And to see how the tidal turbines work in the model, it is presented here. From these figures, it can be seen behind the tidal turbines, which is indicated with these tiny black lines, black dots. It can be seen there is a wake developed due to the impedance of the tidal turbines. So intuitively, it can be seen like at the last row, the productivity when using tidal turbines will be lower. So it is very important to estimate the power by also incorporating the influence of tidal turbines. If observed at one location, this is the illustration of the velocity change induced by the tidal turbines. It can be seen this is a localized speed reduction about 20 to 40 centimeter per second due to the existing of the tidal turbines. And this is at the lateral view. This is at the streamwise view. The first assumption is to have the tidal farms deployed at Panjurit 1, Panjurit 2, Panjurit, and Sangiang. However, there are 3 more scenarios developed, which is scenario 2 where only Panjurit 1 implemented, scenario 3 I have Panjurit 1 and Panjurit 2, scenario 4 I only use Panjurit 4. So this is to investigate the interaction between the tidal farms. And the question is, does maximum turbine deployment produce the most efficient energy extraction? So the result is presented here. The most clear finding is when you have more turbines, you will expect more flow changes as presented in here. This is the normalized change of flow speed. And from this result, also it can be concluded that Sangiang farm has the best potential, which has the highest megawatt hour per turbine. And there is a negative feedback observed between Panjurit 2 and Panjurit 1. So for example, if you have a Panjurit 2, a Panjurit 1 only, you have 130 megawatt hour in 15 days. But if you have Panjurit 2, the value of the Panjurit 1 will be reduced. However, there is a positive feedback between Panjurit farm and Sanggyang farm. For example, if you only have Panjurit 1 and Panjurit 2, this is the value. However, if you add Sanggyang farm into the equation, you will have more power at Panjurit 2 farm and pretty much the same at Panjurit 1 farm. So it is recommended at this kind of strait to deploy both tidal farm in the same time at the west side, at the east side, so it can produce more power. It's a positive feedback. And then this is the final part of the analysis or the discussion, which is a synthesis for general characterization. In here, I compared 6 locations: Chapalulu Strait, Aroy Chut at Aceh, Lepar Strait at Bangka, Sunda Strait at Banten and Lampung, Alas Strait at Nusa Tenggara Barat, Moa Strait at Maluku. So this will be a brief presentation for each site. This is at Sunda Strait. This is the flow field, and this is the current profile during one day. This is at Lepar Strait. Again, this is the flow field, and this is the current profile during one day. This is for Moa Strait, and this is the current profile. And at Alas Strait, again, this is the flow field, and this is the profile. This is at Aroy Chut, at this side at Aceh, and this is the velocity profile. And the last is Chapalulu Strait. This is the flow field, and this is the velocity profile. So if I synthesize what is the main takeout from this comparison, number one is there is a variability in tidal farm position. For example, at Chapalulu Strait, you have a narrow strait with high speed, so you will have the potential location at the middle of the strait. This is the best location to put the tidal turbines. But if you have a medium flow speed and wide strait, for example, at Sunda Strait, you will find the most potential location at the flanks of the islands, at the bottlenecks. And reflected from the case of Alas Strait, you will have like an island just near the coastline, and it will generate the most strongest. The island will be surrounded with the strongest velocity. So this is a unique characterization of tidal energies in Indonesia. So there are high variation in flow speed and geometry. Therefore, the potential sites for each location or each strait will be different. And this one, intercomparison between the tidal curves at each location. This is at Sunda Strait, Lepar Strait, Moa Strait, West Sumbawa Waters, Aroy Chut, and Chapalulu Strait. The first difference is at Sunda Strait and Lepar Strait, there are only one high positive velocity and one high negative velocity. Meanwhile, at other location, you will have 2 pairs of high velocity and low velocity. So this is indicating the high variations of tidal characteristics at Indonesian waters, tidal sites at Indonesian waters. And at some sites you can see the velocity, it's only up to 1.5 meter per second, but at other location you can find the velocities more than 4 meter per second, very strong. So this is a benchmark of an operational tidal turbine at Scotland, which is at the Fall of Warness. That's the name of the location. And the Orbital Marine Power O2 is the name of the turbine. So it's a single floating device with capacity 2 megawatt deployed at 12 to 50 meters depth. And the strait is about 2 kilometers wide. So this is the illustration or the documentation available in their websites. And this is the velocity profile obtained from my colleague's model using Telemark 2D in Edinburgh. It can be seen the peak velocity is up to 3.5 meter per second. So at this kind of velocity profile, it is possible to generate tidal current energy with orbital O2 devices. And I'll compare using this benchmark. I will compare it with location that I have been mentioned, like Lombok or Ala Strait, Sunda Strait, Lepar Strait, and Moa Strait. From this comparison, it can be seen that these tidal sites in Indonesia is significantly lower compared to the fall of awareness, so it's less potential. However, if I compare it with Chapalulu Strait, Aceh Strait, it can be seen that there is a high potential at Chapalulu Strait and Aceh Strait. So it can be hypothetically, if you can take the orbital O2 devices into this area, you can generate a clean energy for the people around the regency of Aceh Besar or Taliabu Islands, which is pretty much now rely on the diesel energy. And this is the closing about discussion and remarks. So I have constructed ocean hydrodynamics model at Sunda Strait, and also doing the modeling for another 5 straits or 5 locations with my colleagues in ITB and also Universitas Pertahanan using Delft 3D. However, firstly, to admit, like, there is still many simplifications and assumptions in the model, so there is still homework in improving the ocean hydrodynamics model, especially fit the model with more robust and adequate field measurement data and validate the model in 3-dimensional form. However, from this modeling exercise, I have presented a demonstration at Sunda Strait showing how the flow and power influenced by the tidal farms, demonstrating there is a positive and negative feedbacks between tidal farms. And from the sites intercomparison, I demonstrate there is a high variability in tidal energy sites in Indonesia. For example, in the potential site positioning, the type of the tidal, and the pattern of the flow. So why this is important? This is important because from a good or adequate ocean hydrodynamic model, the power and the tidal farm design can be optimized, and the power production can be more accurate. And also this information can be fed into the manufacturers to formulate the best operations, the most suitable infrastructure, and improve the turbine specification to suit the capacity or the characteristics of the sites at Indonesian waters. So it will lead to lower capital expenditure and operational expenditure, bring us closer to the implementation of tidal current energy. So orbital O2, Sable, or Minesto, which turbine or technology is most suitable for Indonesian waters? My answer for now, one turbine might not fit for all sites because there is a high variation for Indonesian sites. So we need more modelings, and we need more collaboration with other discipline to develop this science and technology in Indonesian water especially. So I would like to acknowledge, present my gratitude to all that have helped me here. Terima kasih, which is part 1 to part 3 is based on my MSc research supervised by Professor Ven Gopal and funded by Lembaga Pengelola Dana Pendidikan. And in part 4, this is the result from my collaboration with my friend, my colleagues, my lecturers in Ocean Engineering Program in Institute of Technology Bandung, and at Civil Engineering Program at Universitas Pertahanan. And then also some colleagues from RIN and PUPR, Deltares for providing the model license, and also data support from my colleague Tian Tan at University of Edinburgh. So that should be from me. Thank you very much. I would be happy to take any questions. Thank you.
Thank you so much, Mas Munawir. for the interesting presentation. It's very detailed and also very technical, but yet it's still very engaging and also concise. Maybe I will highlight a bit that you discussed in detail about the tidal energy and also the potential sites in Indonesia and also some study cases. While we are still waiting for the question from the audiences, maybe we also already have some questions here. Maybe my personal question first. um, First one, if when you develop the model, I'm curious that do you have challenges, for example, like data availability in developing the model? Can you elaborate more on that?
Yes, yes. That's pretty much the challenge in building this hydrodynamic model. So what I did until now is mostly relies on open source data. And for example, the most crucial data, in my opinion, is the bathymetry data. So as we can see, the highest potential of tidal energy can be found at very narrow strait. However, the open bathymetry data, currently the resolution is like 1 point every 100 meters or 200 meters. Meanwhile, the strait is about 300 to 500 meters wide. So you only have 5 points to represent a cross section, which is not enough. So it is important to conduct more measurement on the bathymetry and also conduct measurement, deploy ADCP to measure the current velocity, the water level, the wave to better understand what is the profile. So we have less uncertainty on the expected power produced. Especially one challenge is we have a large country, as we aware of. So the challenge is this potential location spread from the tip of Aceh to the end, also in the most eastern part of Indonesia, in Papua, and they all have the same equal urgency for clean or even electrification improvement. So that's the challenge in data provision.
Okay, thank you, Mas. And we have a question from Mas Olgavian Adisaputra, and he asked, "What are the most promising areas for future research in tidal energy modeling, and how can advancements in these areas overcome current limitations to boost the viability of tidal energy projects?"
That's very interesting question. So from my experience, I think there are three names of location that came into my mind. Number one is, of course, Larantuka Strait at Nusa Tenggara Timur. It's a bit famous in the tidal energy field, especially in Indonesian waters. It's a narrow strait, 500 meters, and there have been a proposal to build a tidal bridge there. So you have an infrastructure coupled with energy harvesting devices. In addition, Chapalulu Strait is, in tidal energy sense, it's a very beautiful location because the power density or the current velocity is very energetic. It's equal energetic as the site in Scotland. And also another site is at Aroi Chut or Aroi Lempuyan in Aceh, which is also a narrow strait. So you can simply build a bridge to connect two islands and then coupled some tidal turbines below the bridge. So you can have both the infrastructure values and clean energy values.
Okay, yes, thank you. So I hope for Mas Ade it answers your question. Since we have still time, maybe if you have follow-up questions, you can just also write it down in the chat box. We have another question from Anastasia. She asked that given that not all islands in Indonesia have ideal conditions for tidal energy farms, what are the foreseeable obstacles to implementing this idea?
This is very interesting question. So what I would suggest is I would suspect what we will find as or what we will encounter as a problem to develop this tidal current energy or a challenge would be pretty much similar of what has been developed in Scotland, like techno-economic analysis, like how to bring the cost down. So that's what we also need to pursue. Like in here, most of the development is, or many of the development are going on and improving the tidal turbines. However, that's the tidal turbines rasa UK or France. It's the taste or the condition of UK, France water. We have to develop tidal turbines that's suitable for the condition of Indonesian waters. So a larger capacity and more efficient, and also for like remote islands, we need to make it easier to be constructed, or some kind of portable and easy to be maintenance and repairs, noting that the infrastructure itself in Indonesia is very sparsely different between in Java or some crowded islands to some tiny islands, and the many of the tidal energy sites are located at the tiny islands.
Okay, and maybe I also follow-up question on that. Are the research on this topic is already that many for us to really implement, or do we need more research on this?
Yes, we need more. We need more. We need everyone. We need every minutes. We need every computers, every researcher that interested and have ability in this field to be involved, not only in the sense of ocean engineering or ocean modeling, but from the social aspects, the economic aspects, the manufacturers aspect, the policy aspects, because everyone is opening the doors for the other one. So if we keep open access for each of ourselves, we will help this development go smoothly. So what I would suggest, like this might be an interesting topics to be developed by our friends that currently interested in energy systems. So like maybe make a campaign, like let's have like one meeting per month and discuss what's the question now. Let's spend 2 weeks reading some things and then have a discussion, and that kind of campaign can make people more being encouraged to be involved in this kind of research and topics, including you. I think, Sabrina, you can also involve in this kind of research.
Thank you for inviting me. And also, I'm also curious from your point of view, is the topic of the tidal energy is still overlooked when we talk about like energy and maybe renewable energy. What do you think?
I I'm a bit biased on this aspect because I'm in ocean engineering in field in the past 12 years. So at least I have heard about this tidal energy since the past 8 years. But I'm not sure about the perspective from the others. However, I think for now in the industry, the most growing renewables, I suspect, is the solar and also the wind energy, and also the floating solar or floating wind turbine. However, it's more in the UK perspective. So I'm not sure if it's already appreciated or still underlooked. Whether any of them, we need more and more people to develop this research.
Yes, and maybe because your research is very technical, but apart from that technical challenges, what other aspects do you think is important for us to develop in Indonesia? Maybe for the first steps, is it the political will first, or maybe the education for people awareness first? Yeah,
I think I don't have many experience in making many research into one because I'm still in early stage career, so I mainly focus on my research itself. But if I can say something, I would like to say let's make a team, like take one site or two sites or three sites, and let's say it's like gotong royong. Let's do it all of us do it together. Like you do this part, you do this part, you do this part, you do this part. So the sooner we can do like a gotong royong like campaign like that, the earlier we can identify what is the flow, what is the homework on developing this technology.
Yes, okay, but I guess there are like growing discussions about this topic, right? Because you are from the ocean engineering, but maybe from the other other aspects, I think the discussions are growing, I guess. Yeah. So okay, last questions. Wait, let's see. Okay. Um, So someone asks that since you studied abroad and you having the case study in Indonesia, and how are the people seeing the potential in Indonesia? It is also interesting case for them, or how?
Yeah. Unfortunately, I did my research in COVID time, 2019. So
Okay.
I didn't have many times to show off this kind of locations to my friends. Even also there are some conferences it was canceled. However, in the past year, at least I've shown this potential to few researchers in the UK. They are also very interested. However, it is clearly different between the challenge in Indonesia and in Scotland. So, for example, like orbital O2 sites, you have a wide strait, and all of the cross section is have the high velocity, so you can implement many turbines. You can have larger capacity. You can have lower cost. However, Indonesia, the strait is relatively smaller. Therefore, you will have lesser capacity, and then you will have relatively higher cost. So that's the logical. So that's the intuition from the current point of view. But sure, they are very interested with the location. They are interested with the velocity that may exceed 4 meters per second. However, this is still a model. Needs to be confirmed with a real measurement. Nonetheless, have several navigational documents have also indicated the same information, such as a velocity up to 8 knots, 9 knots, which is equal to 4 meters per second.
So even from the technical point of view, there's also some differences, in
Yeah.
Indonesia's case and
That's
different
true.
countries. We have more questions. We have from Abid Arham. He asks, how important is the economic viability in that coupled bridge if it's not economically viable? For example, if it's built on every remote area.
Yeah. That's one thing that I haven't extended in this research. So it is actually I'm not very sure about the cost right now. I don't have any exact numbers on this, but the principles of using tidal energy for remote areas is the cost of energy itself is already costly because they use diesel, which is costly and unsustainable. Therefore, tidal energy might be a little bit expensive technology, but with less carbon contribution. So that's the value of the using tidal current energy at remote areas. And the question about the numbers, we need researchers and people to look into that.
Yeah, so we have to gather people, to talk and discuss about this. We have last questions, and also it's related with also my last questions from Pak Paul. What further research is needed to address the challenges and uncertainties associated with developing tidal energy in Indonesia? So maybe like, what research do you want to do in the future? Or
Yeah.
maybe what's needed in the general?
Yes, from my perspective itself, I have shown that there are 20 locations, but I suspect there are another 10 or 20 more locations that have similar potentials that have not been modeled or explored yet. So if I have, say, 2 years like doing this, probably I would like to spend the time with a team, with a community to explore these 20 locations. And after that, we will have a list, a bank of location with different potentials. And from them, we can formulate which location is the best to develop a pilot project. And then from the pilot project, we can build the confidence in our engineering perspective, economic perspective, public opinion, and then we can move step by step to the tidal area or tidal farms operation, something like that. Thank you for the question, Mr. Paul.
Yes, okay. I think pilot project is really important for this kind of research and also project. Okay, since we don't have any more questions and we also come to the end of the event, maybe I will have a closing statement from Mas Munawir before we
Okay.
close the session. Yeah.
Yeah. So again, I'm very happy to be involved at this initiative, Virtual Academic Dialogue. In Gen Z, we will say this bongkar panggung, the latest presentation. So like, I hope this is a nice bongkar panggung to have a presentation about tidal current energy. Also thank the moderators and all the collaborators that support me in this research and also work together to achieve what we have presented. What I hope in the future is let's learn as much thing as we can, and while learning those things, let's find which areas we can contribute to the people that needs energy, to the people that needs water, sustainability, food, and then let's work together to make this place a better place to live. Thank you.
Yes. Okay. Thank you, Mas Munawir, for the time and the presentations. I think my video is froze, but I hope you still hear me. Yeah, I
Yes.
hope you will build a community and also a team for in the future to discuss about the topic. Okay, thank you so much, Mas Munawir, for the time and presentation. And so we have finished the Indonesia Sustainability Forum's virtual academic dialogue. And this is also a key part of Indonesia International Sustainability Forum 2024. Don't forget to fill the attendance, and also we still have the ongoing vote for the most engaging, impactful, visible, collaborative, visionary, and community-centric. It will be closed tonight, and also it will be announced tomorrow at our social media. So stay tuned in our social media. I'm sorry, my video is frozen, but that's the end of the sessions. I wish everyone a good weekend and also looking forward to the upcoming events, and let's stay connected. Thank you.
Thank you. Okay.